Let's see. We click on that. Should start my stream, I think. Yeah, there we go. We're live on YouTube. Excellent. First week at the new gig. Chill so far. Nice. Nice. I've heard the commute is actually really good. So that's a plus. I'm glad it's going well. Just a big art restoration project, which is not my day job, but it's fun and rewarding. Oh, that sounds cool. And extra dollars. Extra dollars are always good. The business for the father, yeah. Happy Father's Day. Indeed. Oh my gosh. Streaking and lurking at the office. Oh god, Rushing. I don't even want to touch that because it's just like... But you're on a 3-stream streak, so welcome in. Welcome in. Oh, god. Oh, I didn't even look to see. This is how little I have been following. World Cup updates. Stefan RX, welcome in. Good to see you. How are you? How are you? Bored. Hope you're having a good day. Who's been playing Sid Meier? Which Sid Meier? Could you be a bit more specific? What you should be playing. What we should be playing is Rise of Piracy. You know? That way, you could be supporting Irish Strong Games in his game. Testing and prod. Yeah, 100%. If we didn't do that... Update my webcam drivers and I can't use my webcam. Yeah, I was worried that that might happen. It's been nagging me to update the drivers or the software. You know, it's the app. It's not really the drivers as such, it's the app. And, it's been nagging me for, like, 2 months. And I finally was just like, alright, fine. I clicked update now. And, yeah, they're making a short movie. I'll let you know. I'll let you know if it's available after the thing. They do sometimes make them available. The film school sounds really cool. Filmmaking school, I guess. It's not film school. It's all middle school students, and yeah, it's a teacher from a film. So there's a high school around here that has a filmmaking track that you can do. You have to do all the other educational stuff as well, but there's a filmmaking track as a like an elective, I guess. So they have a teacher, and they have other students who've made award-winning short films, and they're all doing this camp. So it's pretty cool. Yeah. Pretty damn cool. Cyan streams with the 6 months at tier 1, subscribed for 45 months, you legend. That's like 17 years. Who even knows how long that is? It can't be calculated by modern computers. Nobody knows. Wow. Our coloring now works. I think that's the 20 gifted that Black Hats Manor did the other day. That's why there's so many... That's why there's so many colored. But anyway, guys, make sure you're following the lovely and amazing science streams. Biologists here on the platform, Blint and Lita, they talk about science. They do microscopy. They play games. They do collabs. All of the things. Go follow them. I know you all know them already. Who did the wizard marry? His ghoul friend. That's terrible. It should have been like, who did the zombie marry? His ghoul friend? Oh, I don't know. That wasn't good. Just got back from Eldest Elementary School. Congratulations. 6 awards? Oh my god. Congratulations, Nick Baring. Congratulations. Ready to take over from Mark Carney already. That's it. They're in. They're in. There you go, guys. Right there. Look, up above. Click the heart. You can follow Science Streams. One of the leaders of science streaming on the platform and a Twitch ambassador. No less. No more and no less. A Twitch ambassador. We get to hang out with science streams once a year at TwitchCon. And we have done... I think we're 4 in a row. I think this will be 5. Or will this be 4? We've done 2 in San Diego and 1 in... Maybe this will be 4 this year. I can't remember. I'm hopeless. I'm hopeless. Dead middle of the week. 2 a.m. on Wednesday. Good. I would hope that it would be dead at 2 a.m. on a Wednesday. If it's like... crazy busy. Hold on. Dogson is messaging me. I think she's going to get sandwiches for dinner. You guys have Jersey mics? Nick Baring! 16 months of tier 1. Thank you so much. The 25-month streak. I'm on day 7. Let's go to bed at a reasonable hour. 7 p.m. proper time. Wow. Ooh, yeah. Yeah, 7 p.m. proper time, 4 p.m. for us. Commute is fantastic. Yeah, I heard that. Just from the bedroom to the downstairs, right? Is what I heard. Oh my god. I forgot. Wait, why is the music stopped? Playlist is finished? Yeah, because the playlist. Yeah, Dr. Knight is gonna get. Do you guys have Jersey Mike's where you live? We have Jersey Mike's here. They make pretty good sandwiches. It looks like it's Jersey Mike's for dinner. Because the girls are out at karate, you know. Our new brown belt is off doing whatever it is that new brown belts do. Doing okay, kind of suspended, waiting for a job call away from home while fogged in at home. So reading a lot and catching up. Well, that sounds actually pretty relaxing, man, so compared to a normal schedule of rushing around Europe and the rest of the world like a Looney Tunes, you know? 2 months ago for the eclipse, I'm only missing a filter. I do have a spare, but so close. You need at least 2 spares, for sure. I know, I keep looking at flights and stuff, Magister. I really would love to come and see it. Even Dr. Nerd is trying to encourage me to go. Trying to encourage you to go. Yeah, that's great news, Nick Barron. That's great news.
In my experience, there's no such thing as luck.
Steph LRX, thank you for the 500 biddies, you legend. Steph LRX, always supporting the stream. I'm very grateful, Steph LRX. Thank you so much. I keep adjusting my glasses. They keep sliding down my face. I don't really know why. You know, they're fine, but they're not. They're like Oakley something or others. They weren't particularly expensive, but they weren't like $20 either. And, I don't know. I'll stop whining anyway. Guys, a level 1 hype train kicked off at 93% already, just like that. Boom. Nick Barring's star is unknown. That is actually in the constellation of Canis Major, I think. Nick Baring. Captain Failure's here. Captain Failure, how you doing? Good to see you. Governor's yet undiscovered star. Yes. Do you guys want a proper dad joke? I mean, if someone redeems it, I'll do the dad joke. You can have the dad joke 3000. It's guaranteed to be hilarious. Guaranteed. 2 peanuts were walking down the street. One was assaulted. Hey, Nick Baring, yes. You may discover your unknown star. Do you still have an unknown star? You see? You got Aldebaran now. You got Aldebaran. So you upgraded for that sub of 25 months. I don't know why it's broken. Who knows? That streams, what was the name of that really cool classical animation style FPS game you played like 900 years ago? I believe Science Streams is only about 850, so I'm not sure. He's like Yoda, you know, he just... Press the distinguished grad. Yeah, 100%. Had some last night. Jersey Mike's? I'm so far behind in chat, I'm having to remember the things that we talked about 10 minutes ago, and that's just like... Jersey Mike's is fine, well and good, but do they have a meatball sandwich? I don't know. I mean, I'm not, like, blown away by it. It's fine. It's adequate. Jersey Mike's, I think. I'll only buy a sandwich. I am too lazy to make it home. Yeah, well, that's... Some nights, there are no sandwiches I'm too lazy to make at home, and some nights, any sandwich is a sandwich I'm too lazy to make at home, you know? It'd be brilliant. I know, Majesty. Yeah, I know. Gotta organize it. Maybe bring Mini Nerd. It'll be an educational trip. Steph is Eri. Wow, I don't even know where that star is. I'm sure someone in chat probably does. Hey, look at that. I'm all caught up. Guys, thank you for the hype train. We are at level 1. You've got 2 minutes. We're 7% away from level 2. 7%. That's it. We're also at... The followers did not dwindle back down below 4,000. We're at 4,017. I think primarily because... Was it the Raiders? It was Coco Confessions. The Coco Confessions or Coco Confession? It's Confession. I thought I had a suspicion. Did that work? Can I spell? Probably can't spell. I think that should work though. Yeah, we had a big raid from Coco Confession the other night, and we got a few followers, and it just has kept us above the above the threshold. So I'm super excited. Anyway, regardless, we will be doing our 4K follow Cocoa, like cocoa nut, I guess. I don't really... It's COCO. That's definitely right. I think it's just delayed because we just shouted out science, perhaps. Potentially. Guys, we're going to jump into some... Oh, we got... Actually, you know what we got to do first? First, we have to do the calendar. We have lots of calendar entries. Okay, well, maybe not lots, but we haven't done it since Wednesday. There it is. It worked. Okay, Wednesday we actually did. That was Toyota's invisibility cloak. For those of you that don't know, the calendar, I got this in the beginning of the year from Dr. Nerd, and it has... You can't see it, because, like, if I put it here... no. It has a scientific discovery from this day, sometime in history. This particular one, June the 18th, 2015... 2015 says silver ants use electromagnetism to stay cool. This sounds like a science streams thing. Biologists from the Columbia University School of Engineering and Applied Science unveiled their research on the Saharan silver ant, which they say can manipulate electromagnetic waves to deflect heat from the scorching desert sun, using only a coat of precisely evolved hairs to control said waves. My God. Science streams, confirm or deny, please. Is this true? Also, I have a question about that. It's all very well to be protected from the scorching desert sun above, but everybody knows the sand is like a zillion and 50 degrees under your feet. So how do they protect themselves? They just have more hair. They have hairy feet. Maybe they're like hobbit ants. All right, we'll put this to one side, and we'll ask science streams. Friday, June the 19th, 2019. REM sleep depends on Goldilocks neurons. Well, all my Goldilocks neurons have moved out, I can tell you that much. Neuroscientists from the University of Bern published their research on the role of so-called Goldilocks neurons in the facilitation of precious REM sleep. These neurons, which experts say are particularly choosy, operate best only when exposed to the absolute perfect ambient room temperature, and otherwise struggle to moderate body temperature and promote... Oh, for God's sake. No bloody wonder, is it? How's anybody? The Hobbit hypothesis. Exactly. The hairy Hobbit hypothesis, possibly LOL links. How you doing, LOL links? They have such tiny little feet. Well, I guess they don't need many hairs, then. Who knows? We could look it up in a minute. June the 20th, Saturday, 2016. Microbiologists find alpaca-derived antibodies. Microbiologists from the Whitehead Institute for Biomedical Research in Cambridge, Massachusetts, discovered that a specific antibody found in alpacas disrupts viral activity in a particularly novel way. The antibodies, named VHHs, or nanobodies, don't actively kill viral material. Rather, these antibodies were shown to instead perturb viruses, disrupting their ability to enter healthy cells and subsequently self-replicate, possibly by ruining their REM sleep, you would have to wonder. Sunday, June the 21st, 2018. Bogong moths use magnetism to aid migration. What is it with these people and their electromagnetism? Bogong moths use magnetism to aid migration. Biologists from the University of Lund in Sweden released their analysis of the bogong moths commonly found throughout Southeast Australia. The report detailed... I'm sorry, but that research just sounds like an excuse to go on a vacation. Like... You're at the University of Lund in Sweden, and you're like, oh, I have to do some research. Let me see. Let me write this grant proposal so that I can go to Australia and study moths. Huh? Sure. I get it. The report detailed the moths' unusual utilization of magnetic fields in their nocturnal migrations. Researchers say this is the first documented case of nocturnal insects relying on Earth's magnetism to guide their migratory patterns. And they also said the weather was lovely. We're almost caught up, guys. Monday, June the 22nd, 2017. Scientists discover early moon's heavy metal atmosphere. Planetary scientists from NASA's Goddard Space Flight Center published a new model simulating the formation of Earth's moon. Most models posit that our moon was formed when a Mars-sized protoplanet impacted Earth nearly 5 billion years ago, ejecting molten rock into our orbit that eventually formed the moon. The new model agrees with that theory, but also describes the moon's early atmosphere and environment as similar to a heavy metal rock star. The theorized violent extremes of the young moon are characterized as one side sitting at 1700 Celsius and the other at minus 150 Celsius. That little dash there was important. With heavy salt winds blowing between in fits of sodium snow. Experts hope this model will help researchers better understand the formation of moon-like rocky exoplanets. All right, and we are with this next one. June the 23rd, Tuesday. That's today. But this is 2018. Scientists recover asteroid fragment in Botswana. An international team of scientists from Botswana, South Africa, Finland, see there they are again, and the United States recovered fragments of an asteroid that impacted Botswana's Central Kalahari Game Reserve. The asteroid, named LA, was only the third to be detected prior to its entry into our atmosphere, and only the second to be recovered. After analysis of the asteroid is complete, each piece will be curated and housed by the Botswana National Museum. There you go. I assume that, yeah, I don't really know what they're talking about. Heavy metal rock stars, LOL links. That was the first thing I thought of as well, was like, you know. Sodium snow doesn't sound good for you, that's a fact. Botswana? Yeah, Botswana got the mensch. I'm going to look this up, actually. Let's see. Wait, we want to look up Comet LA Botswana. Oh yeah, it is here. Look. Oh, it's an asteroid. Whatever. You know what I mean. Super bolide. This is it. Well, this is from April 2021. I was hoping for a bit more of an update. What was that? Was 2018. Almost 3 years since the entry of asteroid 2018 LA into the atmosphere over Botswana. Scientific results generated by 66 authors, collectively known as the 2018 LA Consortium. And after an in-depth analysis of the recovered meteorites, are now out in an article in Meteorites and Planetary Science, one of my favorite magazines. Discovered just a few hours earlier, blah, blah, blah. Magnitude minus 23. That was quite bright. Altitude of 27.8 kilometers. No precise determination of the location. The Okavango Research Institute found 22 fragments, all collectively known as Matopi Pan, including fragment MP19 found by Tim Cooper on October the 12th, 2018. It's hard to tell how big that is. It could be a really small rock sitting on the sand, or it could be, you know, who knows. Anyway, there you go. If you're interested in learning more, about asteroid 2018 LA, you can start there, and you can probably find even more recent updates. Because you know you have to do some sort of research in order to justify your trip. All right, here we go. Here is the make this bigger. What's going on here? Voyager mission managed by NASA's Jet Propulsion Laboratory. Woo! My understanding is that the sand is quite fine in the Okavango Delta, for what it's worth. Ah, very nice. I like fine sand. Okay, let's see. NASA, this is today's A-pod. Before you guys get the treat of watching this JPL production. What would it look like to fly past Triton, the largest moon of planet Neptune? Only one spacecraft has ever done this, and the images of this dramatic encounter have been gathered into a video. Of course they have. In 1989, the Voyager 2 robotic spacecraft shot through the Neptune system with cameras blazing. Triton is slightly smaller than Earth's moon, but has ice volcanoes and a surface rich in frozen nitrogen. The first sequence in the video shows Voyager's approach to Triton, which, with the exception of an overall false green false green tint, appears in approximately true color. The mysterious cantaloupe terrain seen under the spacecraft soon changed from light to dark, with the Terminator of night crossing underneath. After closest approach, Voyager pivoted to see the departing moon, now visible as a diminishing crescent. In 2015, the robotic New Horizons spacecraft famously flew past Pluto, an orb of similar size to Triton. Well, except Triton's a moon and Pluto's a planet. I mean, we all know that. Mustard Goon, welcome in. How you doing, Mustard Goon? Nice to see you. Good to see you. All right, here we go. You ready? I give you the Voyager mission managed by NASA's. Oh, hold on. Let me pause the music just in case they added any. Okay, Voyager 2 at Triton. Got it. Oh my god, we're going to crash. It does look like a cantaloupe. I can see what they were saying there. See, Stephalorix, I kind of see what they mean now. It does look a bit cantaloupe. Cantaloupe? Cantaloupe. I don't know. One of those. Oh, are you okay, man? Owen's sitting in here with me. It's 2 a.m. and I can't sleep. England is not built for 28 degrees. No, this is true. Nor for World Cups, apparently, Mustard Goon. Atmosphere, yeah. Not ripe, slow down. Yeah, you have to, don't you tap on the top or something? You have to tap on the top. Global mapping in 3 colors, orange, green, and blue. Resolution from 40 to 0.6 kilometers. Here, let's go back to the beginning. As Coldplay famous. Back to the start. World Cup hydration breaks. Okay, here we go again. All right. Smell its bottom. I don't never smell anybody's bottom. Entropic. It's just a rule I have. Yeah, see, it looks very cantaloupe right there. I don't know if you can see my mouse right now, but that bit right there looks ready to be sliced open. 15 degrees and foggy. Holy cow, man! Right. Last time I was in the UK, it was unreasonably warm and sunny. Everyone else was loving it big time. Yeah. In Toronto this weekend, not looking forward to the FIFA traffic. Oh no, Steph RX. Uh, yeah. Well, I mean, Europe's melting basically. I'm sure it's just lip. You know, it's not as though scientists have been trying to tell us for decades that temperatures were going to rise to unbearable levels. That's good. Good. I'm sure everything's going to be fine. Yeah, very nice. Very nice. Oh, Schenk. And the image credit. Oh, yeah, the image credit goes to. What about due for an update on Voyager? About due for an update. Oh, that's pretty. Go back to like maybe 100%. Oh, apparently, this one is growing agave in former winemaking regions of France because the climate is suddenly suitable. I mean, it's not suitable for humans anymore. Certainly not humans without air conditioning. Yeah, it ain't good. I mean, I'm kind of surprised that they pivoted so quickly, but it is good. I may have slept on my bathroom floor. Oh god, that sounds uncomfortable though. Guys, play the drop game. If you drop for 99, or possibly potentially more, you will receive, and this is true, a 1-month gifted sub from me. So it's worth a try. Stefan Rice, I'm going to try and bump you here. You got to get a bit lower. Oh, I was trying to help you out. I honestly was trying to help you out. Yeah? World Climate Relay. Oh yeah, guys, you can still get your. We got actually a new donation for the World Climate Relay. We actually did. Wait, that's merch. That was not the World Climate Relay. What happened? World Climate Relay. We are at $2,772. Oh god damn it! Raw Curiosity has got more donations. We're falling further behind. Here's the latest though: $2,772 raised. Amazing stuff. Mini Nerd got another donation. She's at $104. She's in 4th place. What am I talking about? 3rd place. 3rd place on the leaderboard. If you have a couple of bucks to spare, feel free to make a donation. The link is there. Obviously, donate to my team because we got to catch up with Draw. We're $171 behind. Ugh. Never gonna catch up. Alrighty, let's see what this is. The dumbbell. Wow, it is the dumbbell? Looks different. What wavelength is this? You're not supposed to shout Draw out, then people are gonna go and donate even more. I'm just kidding, Miss Adventures. Guys, make sure you're following Draw Curiosity. She's amazing. She's fantastic. Wherever there is danger, she is there. She is danger, Draw Curiosity. Draw's great. She's a biologist, has a PhD, streams science on the platform, and a bunch of other cool stuff. Lots of IRL, does some Pokemon, and has done collabs with me before. We had a Lego off at one point, and nobody's actually still really sure who won the Lego off, because it seems as though mistakes were made. But is this what will become of our sun? Yes, but not for like 5 billion years. Quite possibly. The first hint of our sun's future was discovered inadvertently in 1764. At that time, Charles Messier was compiling a list of diffuse objects not to be confused with comets. The 27th object on Messier's list, now known as, surprisingly, 27, or the Dumbbell Nebula, is a planetary nebula, one of the brightest planetary nebulae on the sky and visible with binoculars towards the constellation of the Fox Vulpecula. It takes light about 1,000 years to reach us from M27. Featured hit, so that's wacky, right? That means it was, where are we? 2026, so it would have been 1026. The Battle of Hastings hadn't even happened yet, when the light that was reaching us from M27 today left the nebula. Good grief. That does my head in. Featured here in colors enhanced by red for hydrogen, blue for oxygen. For now, we know that in about 6 billion years, our sun will shed its outer gases into a planetary nebula like M27, while its remaining center will become an X-ray hot white dwarf star that some nerd in another galaxy may study and try and figure out if that's the source of dark matter in the universe. Understanding the physics and significance of M27 was well beyond 18th century science, though. Even today, many things remain mysterious about planetary nebulas, including how their intricate shapes are created. Let me catch up on chat. Mustagoon says, are you excited for the new telescope in August? Any chance you can explain how good the images will actually be? Oh, Nancy Grace Roman. So I have an inside slight hope that I might actually get to go see Nancy Grace Roman launch. I applied to NASA to go to the launch. That obviously there's a lot of things that have to happen for that to go right. I have to get accepted for one thing. The launch has to actually happen for another thing. If it's delayed by a few days, that would be kind of that would kind of suck. But yeah, I'm really looking forward to it. It's going to be incredible. I mean, the whole thing is absolutely amazing. The grand prize is having a fun time. Yes, this is true. Shout out Baron Bile. Yeah, guys, Baron Bile was on our team as well and raised money. Everybody on the team raised at least a few bucks. Steph RX was on the team. Did an amazing job fundraising. Sun or Sun? Yes. It's going to be great. Basically, a newer wide field Hubble. Exactly. What's to become of our son? He's got to go off to college on his own and make his own way. He's like Dick Whittington, he's going to go up to this big city with his little stick with his handkerchief tied up on it to the intentionally mishearing son throughout this whole description is giving you good business father. I'm glad that you're being Florida Nick Baring. Here, in fact, since you're so fascinated, there you go. Nancy Grace NASA's Roman Space Telescope, or the Nancy Grace Roman Space Telescope to give it its full name, or Roman as people are calling it, arrives in Florida ahead of SpaceX Falcon Heavy launch this summer. It even got its own sign, look. The heavy hitters in space telescopes are about to be joined by a new contender. NASA's Nancy Grace Roman Space Telescope arrived at the Kennedy Space Center in Florida on Sunday, June the 21st, for final tests ahead of launching later this summer. Roman was shipped to KSC from NASA's Goddard Space Flight Center in Greenbelt, Maryland, riding the agency's Pegasus barge from Baltimore to the Space Coast. KSC is Roman's final stop before launching to space aboard a SpaceX Falcon Heavy rocket, where it will join other flagship observatories like Hubble, Webb, Chandra, and Spitzer. NASA is currently targeting an August 30th liftoff, 8 weeks ahead of its original schedule. Hurrah! Before that date arrives, Roman will undergo tests inside KSC's Payload Hazardous Serving Facility, where upgrades were recently completed to prepare for the telescope's arrival. In California, survive the Florida air. Yeah, we get a special rebreather thing, Nick Barron, that allows us to breathe underwater and stuff. Yeah, it's okay. You know, it works. We used to have people following us along with pumps, like they were hand pumping the oxygen. You know, like the diving things where they used to have the big brass helmets and stuff. Used to be like that, but now, you know, we're modernized, so it's pretty good. Roman, inside a specialized, environmentally controlled protective container used to encapsulate the telescope at the start of its journey from Goddard, was transported to the exterior of the PHSF building following its KSC arrival, where teams began a decontamination and cleaning process to ready the container for opening today, June 22nd. Inside the PHSF airlock, followed by the unboxing, that's a pretty big unboxing, and transportation of the roughly 18,000-pound spacecraft to the high bay clean room for pre-launch preparations. Roman's work platform inside the PHSF, which NASA refers to as the Pantheon, will allow engineers to perform final checkouts on the spacecraft, including tests of the telescope's 6 solar panels, installation and heat management components. Technicians will also load Roman with about 290 gallons of hypergolic hydrazine fuel, which will power the satellite's thrusters for delivery to its final orbit, and small positional adjustments during the 10 or more years the propellant is expected to last. Isn't it going to be pretty far out? Yeah, it's going to L2, Mustard Goon. Out with JWST and Planck, as it happens. I think Spitzer's at L2. Hubble is not. Hubble's in orbit, but I mean, yeah, in a more regular orbit. So Hubble's not out there, but most of the big ones are. And you know, now, as we've seen with all the contamination from satellite trails and stuff, you know, that's L2 is your really your only. I don't think we'll see large telescopes launched into Earth orbit like Hubble ever again, because it's just so contaminated. So now L2 is like your option, basically. Good evening, Ella Rain. How are you? I had a great day. I hope you did too. I hope you did too. Oh God, excuse me. Sorry, guys. Apologies. It's been a long week already. Is it Friday? Roman is headed to Sun Earth Lagrange Point 2, or L2, a station keeping point about 1 million miles beyond Earth on the opposite side of the Sun. Wait, what? That's actually not. That's not what they mean. They mean on the opposite side to the Sun. They mean on the 5 more minutes. Okay. Uh, hold on. I'll show you where L2 is if you were. Okay. Here's so this is L2 here. So there's the Sun, there's the Earth, and L2 sits out here. So it's not on the opposite. L3 is on the opposite side of the Sun. You wonder if the author got their Lagrange point and research. Yeah. Okay. They're probably not a specialist, right? So we go down to the bottom and find they have a PhD in astronomy. But yeah, it's this use the wrong word on this. I think they mean. I mean, it says beyond Earth on the side opposite the Sun. I guess what's L2 orbiting? The Sun. So it's a stable point in the Earth Sun system. So it will just sit out here and it'll track around. It'll just track around out here. So it'll make a big orbit. See the difference in this distance here? It's going to make that much of a bigger orbit around the Sun. And it always stays opposite the Sun. That makes sense. L3 looks better. Yeah, the trouble is communications, of course. Then you have to have a relay satellite at L4 or L5. Blah blah blah. It's yeah. Right. Is L3, 4, and 5 just not the same orbit though? Yeah, because look, L3 is on the opposite side from the Sun, right? So, I mean, they're all so L3, 4, and 5 all follow the Earth's orbit around the sun, but they're always in these relative positions. They never move. So, if you rotated this whole thing 180 degrees, L4 and L5 would still be this far away from the Earth. They don't catch up. Like these little green, don't think of these little green dots as orbiting anything. Those Lagrange points aren't orbiting anything. It's the motion of the Earth and the Sun relative to each other which create these points. And those points stay in the same relative positions regardless of where the Earth is around its orbit. So once the Earth, say in 6 months, right, the Earth's position is going to have moved over here to where L3 is, right? So we're halfway around our orbit. Well, L3 is then going to be on the opposite side, back over here where the Earth is now. And L4 will be down here somewhere. L4 will be, I don't know if you can see my cursor very well, but L4 will be down here and L5 will be up here and the Earth will be here. L2 will be out here and L1 will be out here. And then L3 will have swapped places. That's how it works. Yeah, relatives. Yes, yes, yes. There's nothing at those. There's not like a little green planet or anything at those. They're just dots, which I admit is a bit confusing. But yeah, those dots basically. So L5 trails the way the Earth's going. Anyway, yeah, I think L5 trails and L4 leads. And L1, 2, and 3 are just L1 is always on the sun side of the Earth. L2 is on the opposite of the sun side, and then L3 is actually just on the opposite side of the sun. Having a relay sat at L4, L5 would be good for. Yeah, absolutely. Oh, I'm not. Yeah, I think it would be. I'm sure it'll happen because it's becoming increasingly apparent that low Earth orbit is just a waste of time for science, right? So does that make sense now, Masagoon? In fact, if we could find an animation, it would. There an animation, such thing. That's super unhelpful. Surely there isn't. Up. I give up. I should make one. Make a. Let me see. Is this any good? Actually have them moving. Oh yeah, here you go. This part of this video. Well, I guess we could just watch the whole thing. This explains it. I know you can't. I'm working on it.
Spaceship, and you just need somewhere to park it because you're going out of town. Where do you put it? You actually don't have that many options. Most places you leave it, it's going to start drifting away. You come back in a few years,
And you can't remember where you parked.
million miles away.
Can't remember where you parked.
Are
Like Earth, really.
excellent parking spots for your ship. These are called Lagrange points. The Lagrange points are places where the forces acting on an object are perfectly balanced. Assume we have an object that orbits the sun along with the Earth. We're going to use a rotating coordinate system. This rotates at the
It's fine. Don't panic. The coordinates are just rotating. It's all good.
Oh, in this coordinate system,
That is no moon.
Earth doesn't move. Now, let's look at all the forces that are at work here.
Didn't look like a Death
Account for
Star.
the fact
I mean, it could be.
this coordinate system is rotating. We have to add in a centrifugal force that pushes out away from the sun. Then we add in the gravitational force of the sun and the gravitational force of the Earth. This
Not
graph
to scale, I imagine.
shows us the effective potential energy, and it tells us how objects will move. An object whose orbit starts here will slowly drift towards the sun.
Okay, I'm curious in this animation. This is a shadow down here. What is what is the sun is over here? What is making this shadow below the earth? Is there another sun somewhere in this solar system?
An object starting here will slowly drift towards the earth.
What's scale
And an
TM?
object
Hey, Nilf, how you doing?
will
I
slowly
could be
drift
Nerdweenie. I'd be like an Italian
towards our
Nerdweeno.
solar system. But an object won't move if the surface is flat. The surface is flat at 5 points, called the Lagrange points. The first 3 points were discovered by Euler. The remaining 2 were discovered by Lagrange.
Lagrange was a famous was a famous Spanish bullfighter. Actually, he just did astronomy as a hobby. True.
Lagrange points are stable.
Magister will back me up on that.
Object
I'm pretty sure that's right.
off from the point. Its orbit will shift slightly, but not too much. The first 3 points are unstable. This means that if an object is just slightly off from the point, it will just move further and further away. Since orbits near the L4, L5 points are stable, objects naturally go there and stay there. All the major planets have their own Lagrange points, and the most
Absolutely, yeah, exactly. See,
Jupiter has thousands of asteroids clustered around its L4 and L5 points. These are called the Trojans by convention.
so you see how, but you can kind of get the idea here that these points all stay in the same relative position as the Earth orbits the
are
sun. Right?
named after
That was all.
heroes
That was all I wanted to.
Trojan War.
Sort of
The
show.
L4 asteroids are named after the Greek warriors: Achilles, Odysseus, Agamemnon. The L5 asteroids are named after the Trojan side: Priam, Paris, etc.
Good lord.
NASA has been parking spaceships at Lagrange points.
With Planck doesn't get a mensch.
There's even room
Niche
for
submission.
your spaceship,
Food.
as long as you can fly it there. For more astronomical videos, please click to subscribe.
Oh, you know what? Sure, why not? I'll give you a subscribe and a thumbs up. 7-year-old video, but we love it. Although the Spanish may be myth because he was Italian, naturalized French. But hey, Luigi was a bullfighter after all. Exactly. A math matador. Yeah, I'm pretty sure. I mean, that guy, he even looks, he looks pretty much, you know, look, I mean, Louis, is it Louis? Yeah, it's Louis, right? Louis one, I think. What the fuck is going on here? Oh, no. Wait, did I misspell it? Let's see. No. What is happening? Why do I have to not have his own Wikipedia? Am I not spelling it right? Never realized the Trojans were in the Jupiter. Yeah, it does totally make sense when you think about it. It does. It does. South Rebel is here. No, it's not South Rebel. It's designed by Dave. Designed by Dave with the Leroy Jenkins. Guys, go follow. Designed by Dave. Another Southern California native. Builds telescopes. Polishes his own mirrors. Buffs his own lenses. Go follow him. You can see him doing all of that live on stream. Well, some of it. Okay, maybe not all of it. Maybe not the polishing part, but yeah. So some of the stuff on Torino. That's why. Oh, nice. Yeah, you see, we learn something. We learn something new every time we talk about this stuff. Thought it was South Rebel too. Design by Dave. Apologies for mistaking you. I'm sure South Rebel will be shortly. All right, guys, we got a minute until ads. We do run 3 minutes of ads once an hour. Then we're going to be ad free and, more importantly, pre-roll free for an entire hour after that. It'll be the power hour. This is Francesco Antonucci. Speaking of Italians, I assume. I mean, be wrong. Let's see. Ooh, a very nice could have just been wrote. Just beautiful, beautiful work. Did I hear my name? Hey, South Rebel. We spaketh his name, and lo, he appeared. Something. Look at this M31. This is a beaut. As long as we don't water him after midnight, I think it should be fine. I think it should be fine. Guys, we're headed into ads. 3 minutes of ads. I'm going to stretch my legs, give the dog his medicine, and a couple of other things. I'll be back in 3 minutes. Play the maze game! Exclamation point wonder. I will be back shortly. For example, this may cause a background star to appear to brighten slightly as the lens passes in front of it and then dim again. Astronomers can use this effect to infer the presence of very faint objects, like rogue planets, that they can't see directly. One issue with this technique is that the same effect can be caused by a very massive object very far away or a much less massive object that's much closer. This so-called degeneracy between mass and distance is very hard to break with observations from one location like the surface of the Earth, but astronomers have come up with a solution. By using simultaneous observations of a microlensing event from both the Earth and the Gaia satellite located 1.5 million miles from Earth, they've been able to estimate both the mass and the distance of a rogue planet for the first time. You can see how this works in this figure from the paper. Due to the movement of the planet and differences in the path to the two observing locations, the variations in brightness at the background star arrive at slightly different times at the two locations, which gives you an estimate of the distance to the object creating the gravitational lens. Once you have that, you can then estimate the mass. In this case, the astronomers calculated the mass of the planet to be about 22% the mass of Jupiter. There's various ways a planet might get ejected from its parent system, and the velocity of the planet can tell us a lot about which mechanism occurred in each case. All of this data gives us exciting new insights into how solar systems and the planets in them are born and evolve. There's a lot more to this story that won't fit into a YouTube short, so check back later this week for a longer video with all the details. And if you subscribe with notifications on, you'll find out as soon as new content's uploaded. This paper is published in the journal Science, and I'll leave a link in the description. That's today's video. Please drop a like and subscribe to the channel if you enjoyed it, and I will catch you in the next one. We have awesome new images of our newest interstellar visitor comet 3I Atlas. Comet Atlas rounded the Sun recently and is now making its way out of the solar system. Due to its orbit, we can still look forward to its closest approach to Earth on December the 19th, and there are opportunities for citizen scientist observations of the comet on that date. I'll put a link in the description to that project. After the comet recently emerged from behind the Sun from the perspective of observers on Earth, scientists at the Gemini North Observatory on Mauna Kea in Hawaii were able to capture new images of 3I Atlas, only the third interstellar visitor to our solar system to be recorded. In the image, you can see the background stars form a colorful trail of dots as the telescope remains focused on the comet, taking images with red, blue, green, and orange filters. The comet is much closer to us than the background stars, so we keep the comet fixed. The background stars appear to move, exactly the same thing you see when the moon is moving across the sky each night. The images show some interesting changes in the appearance of the comet. As the comet gets closer to the Sun and receives the maximum heating that it will experience in our solar system, we do expect to see changes in the gases and elements that are being released. Sometimes there can even be a delay between when this maximum heating occurs and when we observe the biggest changes, because it can take time. All right, guys, we're back in it. I missed a couple of chats there on the YouTube. Sorry about that, guys. Pandemic entitlement and poor management. Get back to you there. Yeah, and actually, people checking out the YouTube, which is good. That's not my front. I think my dinner might be here. If dinner's here, we're probably gonna do video while I eat. There's some beautiful images in here, though. This is very. Ooh, I like this one. NGC 2174, the monkey's head. Stuff. If you're interested in seeing, oh, relax. Hello. Darwin hasn't. 5 minutes. What if I wire a satellite or something else being sent to space with exclusive EA and S? I mean, sounds expensive, Hugan. Sounds expensive, guys. Let me see here. Oh my god, I'm doing the wrong things. I think we have other. I think we have a couple of other APODs. Yeah, we should. Maybe just one though. Oh, we looked at this already. Oh, great. We're done with APOD, actually. We're finished with APOD. Love that. This is a cool keogram from the other day. We talked about it already. If you want to check out that keogram for yourselves, do it right there. Look. Do it right there. Let me hold on. Let me pull this out. Oh, I also realized that Entropic Universe redeemed dad joke. So I have to dad joke. Here's the button. You guys ready? Oh, I have to turn it on.
Why did the tomato turn red? Because it saw the salad dressing.
Is that not the funniest thing you've ever heard? It is, right? Funniest. You wanted me to do it before we get home? I'll do another one free just for
What did
you.
the grapes say when it got stepped on? Nothing. It just let out a little wine.
I mean, this is the kind of high quality stuff that you can't get anywhere else on Twitch. That level of comedy, you need a professional comedian, which is my audience captive. Dr. Nerd said blink twice if you're being held against your will. All right, there you go, Entropic. There's your redeem. High quality. South Rebel, exactly. But the best quality. Okay, Rocket Launch Live. A quick look at upcoming launches for this week. Tomorrow, 7:48 p.m. tomorrow evening, it will be a Falcon 9 from Vandenberg in California. The 27th, which is what, Friday? Friday or Saturday? It might even be Saturday. It is Saturday. Pegasus, Northrop Grumman mission from the Marshall Islands. Swift boost mission. So this is the one that we talked about. Do you guys remember this? There's a YouTube short on my channel. Is it a short? It might even be a long form. No, I think it was a short. Go check out the YouTube. You'll find this at 7 a.m. 7 a.m. Oh, the Pegasus. Yeah. The Falcon 9 from Vandy is at 7 a.m. Sorry. This is true. Because they're launching from the Marshall Islands. Broke up just like a project. Oh, thank you, sweetie. Yes, I'm aware. I don't know. Turn the AC on. Maybe. Would you mind? It is. Is it? Oh, I could open a window. Is it cool outside? Oh, okay. I'm gonna open a window. Hold on, guys. I can have an in. I used to work at NASA's Jet Propulsion Lab, and I'm going to tell you how a tiny laser on board the Artemis 2 mission turned a 10-day lunar flight into an amazing live HD TV show watched by scientists. Just ran computer. I'm going to tell you about the boldest rescue mission NASA has ever attempted. Drop a rocket from an aeroplane at 39,000 feet, blast into space, grab a tumbling telescope with robot arms, and boost it back to orbit. And they have to do all this in the next 3 months, or the telescope burns up in Earth's atmosphere and is lost forever. Here's the problem. NASA's Niels Grail Swift Observatory is dying. Launched in 2004 to study gamma ray bursts, the most powerful explosions in the universe, Swift has been working perfectly for 22 years. But by the end of 2026, atmospheric drag will make it re-enter our atmosphere and burn up, and there is no replacement mission. So NASA's done something wild. They've given a startup company called Catalyst Space Technologies $30 million and one mission: save Swift before June. Here's how they're going to do it. Step 1, take a passenger airplane, an old L-1011 called Stargazer, and strap a rocket to its belly. Step 2, fly that plane to 39,000 feet. Step 3, drop the rocket in midair. Step 4, the Pegasus XL rocket, which by the way hasn't flown since 2021, fires its engines and blasts into space carrying a robotic spacecraft. Step 5, the robot approaches Swift, a telescope that was never designed to be grabbed, and uses 3 mechanical arms to capture it without damaging anything. Step 6, boost Swift's orbit back to 373 miles, giving it another 10 plus years of life. Missions like this normally take at least 24 months to plan and execute. Catalyst has 8 months from contract signing to launch. They're treating the June launch as firm because no delays are possible, no backup plans. Every day that passes, Swift drops lower. It's currently at 249 miles, and once its altitude drops below 185 miles, recovery will become impossible. 8 months to build the robot, test it, get a rocket that hasn't flown in 5 years ready, launch, rendezvous, capture, boost. The timeline is insane. And it gets weirder. Swift is in a 20.6 degree inclination orbit, almost impossible to reach from most US launch sites. That's why they need the airdrop Pegasus. It's literally the only rocket that can hit the orbit and meet the schedule. This is the first time ever that a commercial spacecraft will capture an uncrewed government satellite. NASA did this with Hubble, but those were astronauts. This is all robots. In 3 months, we find out if a startup can do in 8 months what normally takes at least 2 years. If they fail, we lose one of humanity's most important gamma ray observatories ever. June 2026, and the clock is ticking. Like and subscribe for more space videos like this one. I'm going to tell you about the boldest rescue mission. All right. Oh, not finished with my dinner. Still eating my sandwich. It's pretty good though. Not gonna lie. So that's the mission. Let's see if there's a or something like a more detailed one. Hold on.
NASA is working with an American startup to attempt something no one has ever achieved. Boost a spacecraft before it re-enters the atmosphere.
This is just a really different kind of mission. We can't wait long.
Its orbit has been lowering. If we do nothing, Swift will re-enter the atmosphere, and so there's nothing to lose.
Just a few months ago, this spacecraft was a conceptual drawing.
Catalyst's robotic spacecraft will approach the observatory, carefully capture it, and propel it to nearly its original orbit.
6 months ago, this was a PowerPoint, and it looked nothing like this. In under a year, we're going from identification of a problem, proposal, contract award, to launch.
Saving Swift isn't about just preserving one mission. It's about moving forward in a future where we can give spacecraft a second life.
So that might be what happens, or it could all end in a fiery disaster. We don't really know. Dr. Hubbs, how you doing? Welcome in. Okay. So that launches on Saturday night, I think. Let's see. It's that mission launches. So it's actually Friday. You know, I watched this. This is actually Friday night. So this is Saturday morning at 2 a.m. So this is just after midnight on Friday. I've missed so many things because I've messed these times up. They're in Colorado? Hmm. I missed it, Dr. Hubbs. What did you bounce off? Get one of those crazy side-to-side things? Okay, and then on Sunday there's a Park Online, but that's in the morning. Those are the only scheduled launches. There's a bunch of other stuff coming up. I thought we would talk about this next. The third known interstellar visitor, 3I Atlas, or it may have been a dreadnought. May have been an alien dreadnought. All right, hold on, guys. I'm finishing my sandwich here. Wonder if there's more about this while I finish my sandwich. My sandwich needs to eaten. Ivan Neo, welcome in. How you doing? It was good to see you. What are we looking at? That will tell. I guess here's a quick intro to what Swift does. So, like, if they save it, this is what we'll game. Could be a new Caldari carrier.
For hundreds of years, thousands of years, humans have thought the universe is a very static place. If you go out at night and look into the night sky, you will see that things don't really change much. The universe appeared very static for a long time. We now know this is not true. The universe is a highly dynamic place, and things are happening all the time. Every single second, a star explodes in a gigantic supernova explosion somewhere in the universe. And we have to go and find it. We have to build instruments that are capable of finding those unforeseen events.
Way back in 1998, we were at a scientific meeting in Boulder, Colorado, and I was invited to invitation-only meeting. And at that meeting, 6 of us got together and we came up with the idea of creating Swift. It was a group of people from Goddard and from Penn State.
Swift set out to combine gamma ray instruments that could roughly find out where the gamma rays may be coming from, but only with a very crude estimate. And then, through the design of this remarkable spacecraft, to spin that spacecraft rapidly across the sky and point an X-ray telescope and an optical ultraviolet telescope at the possible location of the gamma ray burst.
Whenever a gamma ray burst goes off, which happens about twice a week, the satellite detects the gamma ray burst and it sends a message down to the ground. And it goes out on a network to our cell phones and we're paged.
What I love being a member of Swift team is carrying a BlackBerry on the side of my hip that became almost like a part of my body. And every time Swift discovered something unforeseen or a gamma ray burst went off, the BlackBerry would start vibrating and I would run to the nearest computer as fast as I could. And this is something I miss now, not working anymore for Swift, this excitement that things can happen at any time and you don't know what it is.
I have on 2 occasions gotten a gamma ray burst alert while I was giving a lecture about Swift. And so I told the audience that here's a new gamma ray burst coming in. And we actually one time got it on the screen and watched the data as they were coming in front of the audience.
I was woken up by GRB 090423. It was 4 in the morning. It was really annoying. It was 5 years into the mission, so GRBs were not so new and exciting then. And I was like, oh yeah, yet another GRB. Dealt with it, went back to sleep, woke up the next morning, and there was information from ground-based telescopes that had observed this gamma ray burst in the infrared that were implying that it was a very distant gamma ray burst at redshift greater than 8. That was very exciting. And the next night, telescopes in Hawaii were able to confirm that redshift, that it's at a redshift of Z of 8.2. That means that gamma ray burst went off more than 13 billion years ago. It's 13 billion light years away. We're seeing light that from a star that was only 7.
That sandwich was very good.
After the Big Bang. That's one of the most distant objects that's ever been detected. That was very cool.
In my case, I had a different experience where it was Thanksgiving, and my family and I had spent a large amount of time working to prepare the Thanksgiving dinner. We had friends round, and everything was ready. The food was on the table, and right as I put my fork into my turkey, my phone went off. Something had exploded in the universe. Swift had detected it, and we had to go to work. So it doesn't always happen at convenient times, but it is still exciting.
Basically, I'm on call 24 hours a day, so it's hard to decide where my personal life starts and where my Swift professional life ends.
As the astronomy and astrophysics community has engaged with Swift, the scientists have learned new ways to use the observatory, and its ability to rapidly follow up new sources has been seen as a really incredibly useful tool. And so Swift has evolved from spending most of its time observing gamma ray bursts and following them for sometimes weeks or months afterwards to doing more science that's proposed by the community to study other types of objects.
We look at supernovae, novae, black hole transients, comets, flaring stars, all different kinds of objects.
Basically, every year, Swift makes a new discovery that changes some field of astrophysics. We have made many, many discoveries in other areas. We've discovered something called a tidal disruption event. That's when a star is falling into a black hole and gets ripped to shreds, and we see the light from that collapse onto the black hole. That's very, very exciting. We've made important discoveries about comets, how much water and how much other material there is in comets that people didn't know before. We have actually seen a supernova, a star that blows up at the moment when the light broke out from the surface of the exploding star. Every year for the 10 years of Swift, we've had one of these really important discoveries.
It is the Cadillac of satellites. It does everything in the transient field. In one package, and mind you, this is a small package, it's an Explorer mission, we have a huge amount of capability.
Swift's ability to observe many objects in one day, I think, is what makes it special, as well as its ability to respond very quickly to new events in the universe. No other mission is as agile as we are.
Swift performs every day 5 to 7 targets of opportunity, so sources that are requested by the astronomers to be observed, and they are observed every day, and this is a very powerful capability that the community is taking advantage of.
All the journals on the wall behind it.
The instrument, I knew its capabilities, but I've been extremely impressed with the team of people that behind the scenes make the mission work. There is a group of duty scientists, mission planners, the flight operations team that make sure that we can continue to observe as many targets as we do. We can continue to do the rapid response that is really unique to the observatory. And without such a dedicated crew of people behind the scenes, I don't think Swift would be nearly as successful as it has been.
Swift mission has been extremely successful in the past up to now, and it will no doubt continue to be successful in the future. And I am sure that a lot of serendipitous science is just waiting for us.
The universe has a lot of secrets that have not been revealed yet. We do believe that Swift can and will reveal
such a cool mission.
Many more mysteries.
Hopefully they'll be able to fix it and get it back into a higher orbit.
We don't know what will happen over the next 10 years, hoping that Swift will still give us exciting data. But what we do know is that Swift will give us exciting new data because of its pure nature. This is what it was built for, to study new, unforeseen, unexpected events. And they will inevitably happen.
It's been a part of my life every day for the last 20 years. I love it. It's produced so much great science, and it's been very fulfilling. But every day I think about
A2E, how you doing? Welcome
delicate instrumentation in the harsh environment orbiting the Earth, and how it's able to keep going all of those years. And I very often will just look up at the sky and think about Swift. It's true.
There you go. Cool. So this is the mission. You know, that's kind of the background. This is the mission that they are trying to save with this launch on Saturday night, 2 a.m. So really, it's what you would think of as Friday night. So maybe we'll stream that. We'll see. The Swift boost mission. I don't know what there's a timetable, like Swift boost mission timetable. I don't know how soon after launch it's gonna render views with the okay. 3 to 4 weeks after launch, the Link servicing spacecraft will approach Swift to verify grab points using robotic arms and LiDAR sensors. It's just gonna grab it by the grab points. Boost phase. Following a successful docking, that's going to be the tricky part. The Swift's ground handling flanges. Link will use xenon-fueled Hall effect thrusters to raise the observatory over a 4 to 6 week period. Once the target altitude of roughly 370 miles or 600 kilometers is reached, Link will detach and deorbit, allowing Swift to resume its gamma-ray burst observations. How cool is that? So this is like bonkers, guys. This mission is completely insane. Like, they've had no time to plan this. I mean, the whole thing has been put together as it goes, and it's got a decent chance of succeeding, I think. The grabbing is going to be the trouble, because most of these satellites that... I'm going to sneeze. Excuse me. Sorry, guys. The grabbing is going to be the trouble, because these satellites weren't... You know, there aren't many satellites in orbit currently. Maybe some of the more recent ones, but most satellites weren't designed to be grabbed like this. So they've had to figure out where the safest places to grab it might be, and exactly what kind of you know, device they need to get hold of it adequately so that they can give it a boost without damaging it. Because if you damage it, then it's kind of like toast. And it's like $30 million or something. It was bonkers the amount of money they did it for. Oh, they've attached the right. Here we go. This is an up-to-date picture. How cool is that? How cool is that, guys? Pegasus on the bottom of an airplane. Gentle nudge. All it needs, she just needs a little boost. I'm not seeing the money. I swear it was like $30 million that they got for do this mission. How much a seat? I mean, you should give them a call. They might take a few bucks. I mean, it would reduce their costs for the mission. Like, if they could sell seats for $1,000 a pop, you know. In all honesty, I'm actually not sure if there are seats inside the plane. It's possible there aren't. Let's see. We can find out about Stargazer. It is NASA Stargazer L10. Oh, I just typed that. That might work though. Images. Let's see. Let's see if we can get a view on the inside. Not. It looks like not. How rude. Oh well. This plane was so far ahead of its time. Yeah, Magister, 100% true. Very true. It would be nice to find Stargazer aircraft. Okay, maybe on Wikipedia. Oh, it was an Air Canada. So it was originally Air Canada. There you go. Oh, it looks so cool. Look at that thing. Giving it a paint job. This is from 2016. It's a cool looking plane. Lucky TriStar, yeah. Yippers. I was hoping we'd see inside, but apparently they're not going to show us inside. It's kind of rude. No, carry-on is not free. Are you joking me? Carry-on is free? You have to pay to use the bathroom as well, Miss Adventure Astro. Free carry-on. What kind of airline do you think we're running here? Like one for the benefit of the passengers? No. There's no free carry-on. Gotta make a profit here. This is all about the shareholders, not the customers, you know? Good lord. Potentially 2E. We're working on that though. We're working on a fix. We're working on a fix for the free oxygen to see if we can make it not free. ESD Publications? What? What's that, guys? Stock up while you can. Yeah, exactly. Get your jars out. I recommend mason jars for oxygen, or possibly tanks. I mean, if you have some scuba tanks, you could store maybe more than average. All right, so that was cool. I did want to share with you. I know we had talked about this before. This is science news, not necessarily space news, but I think it's. Oh, we got to get rid of what's going. Give me a break. Okay, so what we got to look at is this. I know that I don't think I talked about this extensively on stream, but I had posted on social media and copied some social media, like shared social media posts about this. So the National Science Foundation was dismantling this network of, I believe, about 1,600 sensors around the oceans that were critically providing critical data, and we'd already spent all the money pretty much for the whole thing. It was like $330 million. It was supposed to run for another 10 years. And they just started ripping them out because they're like, yeah, I mean, less knowledge is better. Ignorance is bliss. Oh, I'm sure you did. Hey, E to the 2i Pi. Guys, go follow E to the 2i Pi and Shark Geek. Shark Geek is the master of scuba tanks on Twitch. He's like Scuba Doo or something. I don't even know. I don't even know if that joke makes sense. It doesn't really. But yeah, so due to some action from objections from Democratic and Republican lawmakers, this has been halted. They've stopped pulling them out. I don't know how many they managed to get out, but it's been stopped. Hopefully not too many. Hey, Philonox, how you doing? Good to see you. Guys, make sure you're following E to the 2i Pi as well. E to the 2i Pi is a mathematician on Twitch. You guys can follow him over there. And he's a PhD in math. He does all kinds of cool math stuff. Fishing was impacted. Yeah, misadventures, of course. Fishing, weather, I mean, the whole thing was insane from the beginning. The National Science Foundation on Thursday, this was just last week, reversed the decision to dismantle a sprawling ocean monitoring network. See, language matters. Why would you say sprawling? Is it just me, or does sprawling make it sound like it's kind of a waste? And it's like, oh yeah, there's all these ocean monitors. Like, how about the word extensive? How about extensive instead? An extensive ocean monitoring network, because it's freaking amazing. You say sprawling, it just sounds like, yeah, we chucked them out there. It's kind of all over the place. We don't really know. Come on. We can do better. We can do better. The National Science Foundation on Thursday reversed the decision to dismantle an extensive ocean monitoring network after vigorous objections from Democratic lawmakers and scientists who rely on it to track everything from ocean circulation to extreme weather. What's happening? E to the 2i Pi, are you stuck? Do we need a wellness check? The NSF issued a statement saying that it appreciates the concerns raised by the range of stakeholders and would halt efforts to remove or disable equipment. I mean, disable. You're just going to go out there and disable it intentionally. Can't hell. It also said it will redeploy equipment that was already removed from the water and convene an expert panel to determine the future of the network. You were trying to add more spaces? It does need help, guys. Is anybody close by? Can someone go knock on the door? The Ocean Observatories Initiative is a network of more than 900 sensors. Okay, I was wrong. Sorry, 900 sensors built at a cost of $386 million over the last decade. It has tracked ocean circulation, marine ecosystems, climate change, and extreme weather, producing data freely available to the public and informing more than 500 scientific publications. The project was slated to run for another 15 to 20 years. National Science Foundation had directed the removal of most of the system's instruments from the waters off of Oregon, Washington, Alaska, North Carolina, and Greenland by 2027. A decision scientists said came with no warning and no scientific review. The independent federal agency established by Congress described the move not as a cancellation, but as a de-scoping. It's a de-scoping. A de-scoping aligned with a strategy to prioritize evolving scientific priorities and emerging technologies. Trump administration proposed 2026 budget had included a 55% cut to the agency. So it turns out when you cut the funding for a science agency, they start to cut programs. Amazing. On Monday, a group of Democratic senators and one Republican, as well as 2 Democratic House committees, sent letters to the NFS asking it to reverse course on its plan. House lawmakers accused the agency of acting illegally. Surely not. Dismantling the OOI was there's diplomacy in action right here. Dismantling the OOI was supreme stupidity, and we'll keep fighting to ensure scientists, fishermen, and coastal communities, it's not just even coastal communities, those of us inland benefit from this monitoring as well, because it informs weather predictions that for, most of the weather comes from the west to the east, right? So these monitoring stations off the west coast help with weather predictions for the Midwest, and it's crazy. It's all anyway. Democratic Senator Jeff Merkley of Oregon said in a statement on Thursday, ocean observatory cuts were seen as part of a broader retreat from environmental and climate-related science under the Republican administration, because luckily we don't all live in the environment and aren't reliant on the climate to survive, which has moved to scale back research programs, reduce staffing at agencies, including the National Oceanic and Atmospheric Administration, boo, and the Environmental Protection Agency, double extra boo, and ease emissions regulations. Anyway, a bit of good news, a little bright spot in the fucking, I don't even know. Sorry, I didn't mean to curse. A bright spot in the fiasco that is the current state of science in the United States. There's your story. Go check it out. And there should be links at the bottom, I think, about here's a link to the actual the original plan. Oh, they use the same picture. Look at that. Why do you want to save the galaxies? Because of one of these. Listen, yeah, exactly. Exactly, Ivan Neo. Yeah, exactly. Like, good grief. Anyway, I just wanted to share that with you guys. I know we did talk about it briefly, and I think we talked about it with someone who rated in. I think it was, I don't remember. It was somebody that rated in one of their chat was like, "Oh yeah, that's been stopped." All right, we're gonna go back. We're gonna go back to interstellar spacecraft now. As you all know, that is what 3i Atlas was. It was possibly a dreadnought, an alien dreadnought. Why doesn't Donald Trump trust the scientific method? Because every time it gets new evidence. Yeah. An interstellar comet that blazed past the sun last year, allegedly, could be nearly 3 times older than our solar system and is unlike anything ever seen before in our cosmic backyards. Astronomers said Monday. I think this was like Monday, like yesterday. Pretty sure. Yeah, June 22nd. What? Yeah, yesterday. The comet 3i Atlas is just the 3rd visitor from beyond our solar system that humanity has ever observed. I mean, you would have to think that it's sprawling. It's sprawling. You would have to think that there have been many more, but this is the 3rd one that we've actually detected and been able to. How do we know it came from outside the solar system? Because we look at its orbit and we can see that if you track back the orbit, that it heads back to some like point many millions of light years away in the galaxy. After being spotted in July of last year, the space rock prompted excitement online.
Allegedly.
Hogan698, welcome in. Good to see you. How you doing? This is funny. After being spotted in July last year, the space rock prompted excitement online with one prominent Harvard researcher, who shall remain nameless, speculating it could be an alien spacecraft, a theory that NASA shot down, that every sane person on the planet shot down. Anyway, now observations by the world's most powerful telescopes are revealing more about the unique comet. I still think that the 3i Atlas video that I made is still my best performing video on YouTube. It's got like 120 something thousand views. It's insane. And it's all just people arguing in the comments about whether it's aliens or not, I'm pretty sure. Now, observations by the world's most powerful telescopes are revealing more about the unique comet. I said that already. According to a new study published in the journal Nature, 3i Atlas could be up to 12 billion years old. 12 billion years. Our solar system is believed to have formed around 4.5 billion years ago. 12 billion years is getting on for the age of the universe, right? We think the universe is like 13.8-ish. Unnamed researcher, yes, the chair of unnamed studies does say that everything is aliens. He is kind of funny, though. I mean, it's free entertainment, you know? Free entertainment. We're completely, by the way, chat, not talking about Avi Loeb here, okay? I don't want you to get the wrong impression. Lead study author Martin Cordner of NASA's Goddard Space Flight Center told AFP that maybe it's the oldest object to have been observed in our solar system. However, there could be edge case scenarios, in quotes, that offer other explanations for the comet's unusual chemical composition, he added. New research is based on the comet's ratio of chemical elements called isotopes, detected by the James Webb Space Telescope and the ALMA Observatory in Chile. These measurements reveal an elemental composition unlike any solar system body, the study said. So, they're agreeing that it is aliens, then. Yeah, well, mothers-in-law to just live, well, I should say that. Might pass away, but my mother-in-law was a lovely lady. Guys, play the drop game if you drop for 90... if you drop for 99 or more, you get free 1 month sub to the channel. True story. It is a true story.
Allegedly.
Am I muted? I shouldn't be muted. Don't believe so. I don't think so. I didn't touch anything. I didn't break anything. I promise it wasn't me. It was not me. Okay. Relic from cosmic noon. Compared with comets in our solar system, 3I Atlas had around 30 times more deuterium, a type of hydrogen commonly seen in heavy water, according to a NASA statement. That high abundance of heavy water can only really happen, according to our understanding of astrochemistry, in a very cold environment, Cordner explained. This means the comet is also likely among the coldest objects ever seen in our solar system. The isotopic evidence suggesting it formed in an environment that was minus 243 Celsius, or minus 445 of those F things. Who's asking me to mute? I could do that too. Exactly where this comet came from within the Milky Way remains a mystery, but these interstellar objects are thought to form in a similar way to the comets in our solar system, being flung out during the violent formation of a new planet. Untethered to any star, 3I Atlas likely spent billions of years on vast, unimaginable trajectories around our galaxy, Cordner said. The scientists also detected a strange lack of chemical enrichment on the comet, which suggests it formed relatively close to stars being born. I lost my place. Been born. It could even be a relic from an era called cosmic noon, when many stars were forming around 10 billion years ago, Cordner said. The previous interstellar objects, 1I Oumuamua, which was spotted in 2017, followed by 2I Borisov in 2019, were not bright enough to gather isotopic evidence. Harvard professor Avi Loeb, who had previously sparked controversy by suggesting Oumuamua could be an alien spacecraft, made similar suggestions about 3I Atlas. However, NASA has dismissed this possibility. The Search for Extraterrestrial Intelligence Institute said last month that it had found no evidence of extraterrestrial technology on the comet. Steve Croft, an Oxford University researcher with SETI's Breakthrough Listen initiative, told AFP that all observations of the comet are consistent with it being a natural astrophysical object. Do you know anything about Nancy Grace Roman? We were just talking about Nancy Grace Roman at the beginning of the stream, Hogan. Yeah, we're super excited. We are super excited to see what it can do. There's a small chance I might get to go to the launch. We'll see. I have an application in with NASA to see if I could go. You know, that would be super cool. Oh, $49.99. Quick Nails, welcome in. Good to see you. It also occurs to me that the music is. Web is such a fraud. He needs to be heated. Dr. Nazimo, welcome in. Guys, go follow Dr. Nazimo. He's another scientist here on the platform. Oh, have I got something for you, Dr. Nazimo? I don't know if you were here the other day. It is a Father's Day gift. It is the Dad Joke 3000. And are you ready, Dr. Nazimo? Are you ready? Are you ready?
What do you call a bear with no teeth? A gummy bear.
A gummy bear, get it? Because he hasn't got any teeth, so he's a gummy bear. He's a gummy bear. beg it. You don't get it. Yeah. See, it's because the bear doesn't have any teeth, designed by Dave, and that means that all he's got is gums and a gummy. I'm not even getting involved in this. I'm not even getting involved in this. How does Roman block out the light from the star being observed? It's wide field, Hogan, so it's observing many, like a big wide field of view. A big wide field of view all at once. So I don't know. It has a coronagraph as well, so it uses. It is unbearable. You'll have to bear with us though, designed by Dave. Bear with us for a little bit longer. Yeah, it has a coronagraph. So coronagraphs typically just have a physical uh a physical block in the light path that blocks the central light from the sun. Is that what you meant, Hogan? Yeah, coronagraphs. So that we have many different coronagraphs. Some on Earth-based telescopes, some are in space-based telescopes, and yeah, you essentially just literally have something in the optical path that blocks the central light. Usually, that's how you do it. Because you can't do it in post-processing, right? Because you would have just saturated the detector. So the idea is that you want to block out as much of that light as possible without blocking out the light of whatever it is you're trying to observe. So it's kind of tricky. It is a bit tricky. Yeah, the coronagraph, yeah. Just the beginning. Several astronomers who have studied 3I Atlas but were not involved in the new research hailed the unprecedented results. Until these measurements, we could only really dream about getting this kind of information from an interstellar object, Darrell Seligman of Michigan State University told AFP. He cautioned that the comet's age remained uncertain, adding it was a safe bet that that it is older than anything that formed in the solar system. Astronomer Peter Veres, who was involved in identifying the comet at the IAU's Minor Planet Center, called the research exciting. The comet is now leaving the solar system and will never return, so future observations will become increasingly difficult, he told AFP. However, astronomers expect to spot many more interstellar objects in the coming years, particularly via the new Verisi Rubin Observatory in Chile, which we've talked about that before. Is this a new paper on composition? Yes, Dr. Nazimo. Yes. Do you have any expertise to offer? Have you had a chance to have a look at the paper? I know it was only published like a couple days ago. Well, you probably saw the Astro PH a while ago, but this is just the beginning of an exciting new field. We've got a lot more to learn about these things and what they can tell us about our galaxy, Cordner concluded. There you go. Here is the story, which I think is cool. Only saw a few plots. There's a link to the article that we just read, and here is the paper, which hopefully is open access. So this is an unedited manuscript, it says. But it's accepted for publication. I don't really know. There may be errors. Okay. There may be errors. Oh, it is. It's not open access. What is happening? What actually is happening here? You have full access to this article via your institution. I actually. Oh, I can download the PDF. I don't think they meant to leave the PDF to be downloadable, but okay. I'll accept your I accept your apology. Go grab it. Go grab it while you can, guys. Pretty sure you're not supposed to be able to do that. Maybe it's not the paper though. Maybe it's like some kind of scammy PDF thing. No, it's the paper. It doesn't seem to have any figures in it though. I don't understand this. I really don't understand why we're doing things this way these days, but oh, are the figures at the end? And oh, here I finally found. Okay, I'm gonna have to read this. Could be open access. It looks like it's open access, but then when you try and read it, it's not actually here. You know what I mean? Wait, is someone from JPL involved in this? I just saw a JPL flash by there. Pinocchio. Okay. Yeah, I guess it's just the PDF. I don't know. Hey, Cliff41, welcome in. How you doing? Good to see you. Good to see you. Did you see any telescope-related deals on Prime? No, I didn't, but maybe Misadventures did, or anybody else. Anyone with any Prime Day deals? Much as I hate to support, you know. Includes parts of telescopes. I mean, a lot of the telescope stuff on Amazon, to be honest, is just kind of junk. There's some good stuff, don't get me wrong. Accessories probably more so than the actual telescopes. Like power bricks that you can get. Like there's an SV Boney power, I don't know what you call it, distribution thing that they have. That's pretty cool. That actually is on sale. It's tempting at this price. Okay. I'm just gonna give you one link. $37.99. I think I paid $60 for mine. I think I paid $60 and it works great. So if you're in need of some kind of USB power supply, I can highly recommend that one. And at $38, that is a steal. As I think Magister has one of those as well. And the other one is on sale as well. There's a bigger, beefier version. Yeah, it powers my stuff. Yeah, absolutely. Oh yeah, it has DC outputs that'll do 10 amps. I mean, it has a lot of power. There's plenty of power there for all of your needs, kind of thing. The Pro one is on sale for $135. What's the big difference? Is it just more ports, Misadventures? Oh, I hate to put another massive link in chat, but 10 amp output, that comparison of it. Only at 5 or 12 volts though, right? Sofa King Lethal, not 120. It could power a really small server, maybe. But yeah, they're good. They're good if you do a lot of field work, and it gives you. I basically have 3 telescopes hooked up to this because I have my guiding camera connected. And then I have my both imaging cameras on the 2 telescopes, both autofocusers, and something else as well. I don't remember. I don't power the mount from it, but everything else I do. So more ports, more power outputs, and more possible configurations. Not perfect, but with the price grade. Yeah. I think the smaller one for $37.99 is an absolute steal. I'm tempted to put it in my cart right now. Honestly, definitely powers a Raspberry Pi. Yeah, it would.
Jenkins.
Big Gamey is here. How you doing, Big Gamey? Good to see you. We were just discussing Prime. Did you take advantage of any Prime Day deals today, Big Gamey? No, you, Big Gamey. No, you. Do we still have a no you thing, or is that broken? I haven't done it for so long. Does it work? Oh my god, it works. Oh my god, it actually works. How you enjoy, guys? Make sure you're following Big Gamey. He's a legendary streamer here on Twitch. Does game dev and also plays games on his fancy new PC. Yeah, you see, you didn't know that, did you? But he is actually gaming on his PC. Your money, so no spending. That does definitely cut down. Hey, Bill Nash is here. How you doing, Bill Nash? Good to see you. Yeah. Yeah, I'm tempted by one of those because I have all these USB hubs, right? But they never pull enough. If you want to actually power things from them, they really can do it. This SV Boney thing actually can. It actually does provide the kind of current that it says. No more potato streams. Yeah, well, unless we're screaming about potatoes, right? So, also, guys, happy Asteroid Day. Did you know? Did you know it's Asteroid Day? It is. It's a fact. Hope you sent your favorite asteroid a card. Maybe got them a small gift. I thought we could talk about this paper. It's kind of interesting. It essentially makes the point that as we go further from Earth, it's becoming... I believe so. I believe so. Jackie Lawson didn't send me a reminder. Oh, it's next Tuesday. I got the Tuesdays wrong. I'm confused. Next Tuesday. Next Tuesday, I lied. It's the 30th, not the 23rd. But we can have two. We're going to have two. We're going to have two. We're going to run through this real quick, and then we'll probably... we might do some JPL. Another JPL video after this. How are we doing for ads as well? Oh shoot, ads are coming. All right, let's see if we can get through. Let's see if we can get through this before we get hit by ads on Twitch. And if you're on YouTube, stick in there. We have to run 3 minutes of ads once an hour on Twitch, so we do take a bit of a break. But you'll go to the BRB screen. You'll be able to watch some of my cool YouTube shorts. So cool. Hey, take it easy, Hogan. Off to work. Ad Astra, yes. Clear skies. For decades, astronomers and policymakers have been working on plans to protect our planet from killer asteroids. But now to be clear, the asteroids could not care less. They're just doing their thing. But now there's a new realm to protect: the thousands of satellites we're putting in orbit. Hooray! And that's just the start. Future off-world infrastructure, ranging from orbital fuel depots to moon bases, could be hit by asteroids, meteoroid storms, or other threats from above. Aliens, for example. A new proposal to identify such threats and do something about them has earned 2 researchers from the University of Edinburgh this year's Schweikart Prize, which is named in honor of Apollo 9 astronaut and planetary defense advocate Rusty Schweikart. As human activity and vital interests rapidly expand into regions beyond the protective shield of our atmosphere, the number of passing objects capable of causing serious damage to life and critical infrastructure increases dramatically, Schweikart said today in a news release. Our Schweikart Prize winners this year have called for a comprehensive and systematic examination of this emerging reality. I mean, you've got to kind of admire people who can read a room. They're like, Schweikart Prize. What's this guy into? Ooh, planetary defense. All right, I got it. Let's go. The winners, Brian Murphy and Richard Cannon, are due to receive the prize at Lowell Observatory in Arizona on June 27th. Schweikart Prize is a B612 foundation program that encourages graduate students to come up with fresh ideas aimed at defending our planet from near-Earth objects, or NEOs. Winners receive a $10,000 cash award as well as museum-quality trophy with a meteorite on top. A museum-quality trophy, and that's actually clickable. That's a beauty. That is a beauty. No question. Museum quality. Past prize winners have proposed methods for spotting asteroids coming at us from a difficult-to-monitor zone between Earth and the Sun, or for managing future risks associated with asteroid mining. This year's winning proposal focuses on potential threats posed by streams of space grit, or by space rocks far smaller than your typical asteroid. As Schweikart noted, these cosmic bits would burn up in our atmosphere, but they can do a lot of damage in the vacuum of space. Murphy and Cannon propose setting up an international commission to assess the threats to space infrastructure in Earth orbit and beyond. That would lead to the creation of a coordinating body to build on the work currently being done to anticipate asteroid threats. So their suggestion is to set up a committee, it seems like. Here's my suggestion. You should start a committee. That will be $10,000, please. I mean, it's good work if you can get it, I guess. I don't know. The researchers call their proposed coordinating body WARDEN, which stands for Warning Network for Asset Resilience from Dust, Ejecta, and NEOs. Ah, see, you'll do it for 9? No. I already won, Mr. Ventus. It's too late. See, they came up with a good name, Warden. I mean, Murphy, whose research focuses on planetary defense missions and the composition of comets, said the idea for the proposal came to him in a dream. I had a very vivid dream that there was this meteoroid storm impacting Earth, and I woke up in the morning and I said, I need to check that out. What, your dream? Is this related to the Schweikert Prize? Could I submit this, he recalled. Wow. Amazing. What a coincidence. He had a dream, and he submitted a proposal, and... the wackiest thing I think I've heard. Satellite operators have long known that meteoroid storms can ruin their spacecraft. They typically reduce the risk through shielding by special maneuvers aimed at minimizing a satellite's exposure during a predicted storm. But protective measures don't always work. This is true. In 1993, meteorites from the Perseid meteor shower are thought to have led to the demise of the European Space Agency's Olympus 1 satellite, and scientists suspect that a Perseid meteoroid dealt a blow to the NASA USGS Landsat 5 satellite in 2009. All right, guys, we will finish this. There's not too much left. We'll finish this after the ad break, and then we'll get back to some JPL history, I think, just because that's been super fun. So, guys, play the maze game! Exclamation point Wanda in chat. If you're on YouTube, sit tight. We will be back in 3 minutes once our ads have run. Guys, BRB. We have new images of interstellar comet 3I Atlas from the Gemini South Observatory, an 8.1-meter telescope located in the Chilean Andes. As you can see in this image taken on August the 27th, 3I Atlas is starting to develop a tail as it gets ever closer to the sun and heats up. To me, it looks as though the coma has become more pronounced as well, which is what we expect as the nucleus of the comet is heated by the sun and the ice there starts to sublimate, turning from frozen ice to gas. As that happens, some of the dust and rock trapped in the comet is also released, so it'll be interesting to see what elements we can detect there and whether these elements differ from what we see in comets that originate in our own solar system. If you're wondering what the multicolored streaks are, those are background stars. The telescope is tracking the comet, and that's moving across the sky much faster than the background stars, so if you focus on the comet and take a long exposure, the background stars will appear like streaks. We'll get much more data on 3I Atlas in the coming weeks as it heads towards its closest approach to the sun on October the 29th and its closest approach to Earth on December the 19th, although it will still be 167 miles away from Earth on that date. That's today's video. Please like and subscribe if you enjoyed it. I will catch you in the next one.
Check out this incredible image. It's a disk of gas and dust surrounding a young, sun-like star called Wispit 2 that's just 5 million years old. If that seems pretty old, compare that to our 4.5 billion-year-old sun. The ring structure you can see indicates the presence of forming planets interacting with the gas and dust in the disk gravitationally and clearing out their orbits. That bright yellow dot you can see, that's the first direct observation of a newborn planet in a multi-ring system, and only the second such planet directly imaged around a younger version of our own sun. The planet, called Wispit 2b, is around 5 times the mass of Jupiter and orbits around 57 astronomical units from the star. That's 57 times the distance from the Sun to the Earth, and the whole disk system is around 380 astronomical units across. These stunning results were produced by the Wispit project, hence the name of the star, using the European Southern Observatory's Very Large Telescope and the SPHERE instrument. Wispit stands for Wide Separation Planets in Time, and it's a survey project to detect and study planets orbiting further than 50 astronomical units from their stars. If you're wondering why you can't see the central star, Wispit 2, it's because SPHERE is a coronagraph, an instrument designed to block the bright light from the central star, making it easier to spot the much dimmer planets and protoplanetary disk. In a new paper published on August the 26th in the astrophysical journal Letters, you can find this image that shows the various rings the team were able to identify along with some gaps. The data was taken from 4 observing sessions from October of 2023, October of 2024, and March and April of this year. Astronomers have long speculated that planets would create this kind of ring and gap structure as they form in a protoplanetary disk, and now we have our first direct evidence. The team also present evidence that the planet formed at its current location in the disk and did not migrate inwards from further out, which is another possible theory. Follow-up observations with JWST and ALMA should shed even more light on this fascinating system, and it'll be interesting to see if Wispit discovers any more stellar systems like this one. That's today's video. Please like and subscribe if you enjoy it. I'll catch you in the next one.
NASA's Jupiter Icy Moons Explorer, or JUICE mission, will arrive at Jupiter in July of 2031, where it will study both Jupiter and its icy moons Ganymede, Callisto, and Europa. All right, guys, back. Yeah, so let's finish this up. Since 2009, the number of satellites in orbit has mushroomed from fewer than 1,000 to more than 17,000, mostly because of the expansion of SpaceX's Starlink constellation. Murphy and Cannon estimate that the exposure to meteoroids has increased by a factor of 10 to 100, and that the risk will increase exponentially as more commercial ventures build out their satellite megaconstellations. Even when we had 100th of the assets in space, there was still damage that was in the $1.2 billion range, Murphy said. You can do the numbers for yourself there and say, all right, if we have 100 times that now and potentially 1,000 times that in the next decade, this is going to be a big problem, and we need to start addressing that question now. I mean, I guess we could definitely... In their proposal, Murphy and Cannon even lay out deadlines for doing something. There are meteoroid storms coming back in 2028, 2033, and 2034 that historically have been damaging to spacecraft in the 1990s, as well as some of the biggest meteoroid storms ever recorded in the 1960s, Murphy said. The 2028 event is predicted during the Perseids that August, while the potential storms in 33 and 34 are associated with November's Leonid meteor shower. Is the meteoroid threat on the radar for satellite ventures? The short answer appears to be yes, thanks in part to the fact that protective measures are already being taken to address the impact of satellite collisions in orbit. SpaceX, for example, equips its Starlink satellites with extra shielding. Extra shielding, that should work. And it has a procedure for reducing a satellite's exposure to impacts by flattening its solar panels. That sounds a bit more reasonable. The engineers at StarCloud, a Seattle area space venture that eventually plans to launch tens of thousands of data center satellites, are also aware of the issue. Right now, we're very focused on the engineering for the first and second satellite, but it's something we will put more time into as we build out the constellation, StarCloud co-founder and CEO Philip Johnson said in an email. Looking beyond Earth orbit, the Warden system that Murphy and Cannon proposed would monitor potential threats to space infrastructure extending as far out as the moon. Last year, NASA reported that a building-sized asteroid known as 2024 YR4 had a small chance of hitting the moon in 2032. I believe that is gone to zero now. Ed Liu, executive director of the B612 Foundation's Asteroid Institute, said an impact by an asteroid that large would result in a pretty big explosion and create a 2-kilometer wide crater. Obviously not ideal. NASA eventually ruled out an impact, but the episode served to illustrate the cosmic risks that future moon bases would have to contend with, perhaps starting in the 2030s, allegedly. The risks could come not only from passing asteroids, but also from cometary fragments or the debris blasted into space by future asteroid mining operations. I have an idea, though. What about if we didn't do asteroid mining? We could reduce that risk down to zero. Murphy and Cannon argue that the international bodies currently tasked with monitoring potential asteroid threats to Earth, International Asteroid Warning Network, and Space Mission Planning Advisory Group, aren't well positioned to focus on off-Earth threats and don't have such a cool acronym. Oh, sorry, they didn't say that last one. Murphy said adding Warden to the mix would create a trifecta of planetary defense. They all are checks and balances to each other rather than two systems that could be at odds with planetary defense. I don't even understand some of this. So where does the proposal go from here? The next step is, first of all, engaging with the expertise that is present, Murphy said, because I don't know a damn thing about this. Primary way that we'll go about that is through Cannon, my co-author, as well as my network within the small body community. Murphy and Cannon plan to use their $10,000 award to fund meetings that will result in the creation of the International Commission on Space, Infrastructure and Resilience, or ICSIR. Our first ICSIR meeting would be at the University of Edinburgh in Scotland, Murphy said. We want to have potential meetings of ICSIR roughly every 6 months following the first meeting and really keep that momentum going and also have an online presence. The way Murphy sees it, the winning prize is just the start of something far bigger, an excellent night down the pub. No, sorry. We're about to expand to the final frontier, further than we've ever gone before, and bring with us the critical infrastructure for our civilization, he said. So we simply must evolve planetary defense to protect that as well. If you're interested in the Asteroid Day post, I wonder if they were meant to post that next week. Who knows? Who knows? I thought it's kind of cool, though. It's definitely something that needs more attention, right? It's definitely something that needs more attention. Okay, let's jump over and hit up some JPL. Where are we at? The Explore series, JPL in the Space Age. What were we up to? We just did JPL on the Space Age of the Pathfinders. JPL on the Space Age Breaking Point. Oh god, this one's 2 hours long. Okay, well this is going to be a multi-stream effort, but we'll get a head start on it. Oh, there's JPL. That's the JPL I recognize.
I don't think we can afford to fail. I don't think failure should be an option.
No, failure has to be part of the equation. You can't have stunning science without failure.
Only 3 people at once in the air shower. I mean, it sounds a bit...
I think the people who have success without having failure don't appreciate it nearly as much as those of us that have lived through the failures.
The laboratory doesn't seem to acknowledge the failed missions, have kind of disappeared.
It's interesting. When there is a loss, people who suddenly go away, who don't want to be associated with the failure, or who don't want to set the record straight. We want to bury our losses.
I think that it's the pain we can't accept. I think it's the personal anguish, the damage to the reputation. That fear has kept us from being even bolder than we have been, although we've been very bold.
We hurt ourselves by describing the process in terms of winners and losers. You don't know how close you are to the edge. And I put the successes and the failures about 1/8 of an inch apart.
So we stumbled, but let's go back and see what we can learn from that and try it again.
Sorry guys, I was just redoing that for the YouTube. Anyone win the drop game yet? No. Bad, huh?
Kind of a neat place to work because it really rewards energetic, smart people. You have people in the lab that have been working here a few years and they talk about, they ask, how do you advance? There's 2 keys to success at the lab, really only 2. Credibility and visibility. Sometimes easily gotten, certainly easily lost. Lab's nestled in these hills, it's pretty, it's a big place, a lot of walking. And
this is kind of funny.
These cool badges.
In the late 1990s, NASA's Jet Propulsion Laboratory was on the verge of a new era of exploring the solar system.
It's like I don't even know what that's like, but that's quite the recruiting
Just ahead
video.
were 6 new missions slated for launch.
So the coffee place. This is a little mall down here on the right, bottom right corner. It was really good. That was where we used to be able to sit and have a coffee and chat and have
In
meetings.
just 6 months, an unprecedented achievement. There were 2 new spacecraft to target comets.
Yep.
One would test a new propulsion method.
Yep. We cycled on some of those streets.
Star Trek. While the second
I think we went down that hill that he was going down, actually.
And bringing them back to Earth.
Pretty sure. We just turned right at the traffic light.
A space telescope would search for the birth of galaxies. For our own planet, there was a satellite to measure wind speeds across the oceans. And for Mars, there were 2 new missions. The Red Planet became a major destination following the discovery of a Martian rock that some believed contained fossilized microbial life.
Something really, really huge that's going to be taking place over the next 10 years as we send many missions to the Red Planet. And usually one of the most asked questions regarding Mars is there life on Mars? I think there is life out there somewhere in the universe. I don't believe that we can be the only beings in the universe. So I definitely think there's somebody out there watching.
The hair. I wasn't going to say it, but yeah, the hair was spectacular, no?
These new missions were signs of how far director Ed Stone had steered JPL in a new direction. One that emphasized smaller, less expensive, but more numerous missions.
I had come to believe that we had done the major global exploration missions, and we really needed to move on to a new frontier. And the question is, what was that frontier going to be?
The new frontier had a name: faster, better, cheaper. It required embracing aerospace companies as partners and giving work over to them. And agency officials were to be viewed as customers to be satisfied. The new watchword was, make a deal and stick to it.
If we're going to continue exploring the solar system, our engineering challenge, our science challenge, is to find ways to do that at lower cost.
The changes underway also included staff reductions, even as missions were going out the door to industry that was hungry for work following the end of the Cold War.
We agreed to reduce the size of the staff at JPL by 1,000 over a several-year period. Well, when that was announced, it was a bombshell. The laboratory had never voluntarily reduced its staff.
I'd like to hear from you on what are you concerned about? What are you worried about? What are you fearing at this time?
It was very difficult.
That's a trick question, by the way.
Explain or justify to the employees who were concerned about their job, and said, look, why are you doing this? You don't have to do this. My budget hasn't been cut. Why me?
One of my concerns is that there is...
It colored everything we tried to do. It was a grinding downsizing, you know. Every year you'd ratchet down a little more, and a little more, and a little more.
But back in the back there?
What should I be doing? Where should I be going for careers? Things like that. Are we going to build spacecraft, or is that industry? Where to go and what to look for in the future is real confusion. I'm not sure where to go with it.
Yeah, well, you might ask, what does our customer in Washington expect of us, right?
My level, I have the slightest idea of that.
Faster, better, cheaper.
Really comes back to the basic point, though, that JPL, the reason there is a JPL, the reason there is a federally funded research and development center for NASA is to do things nobody else can do. And so we have to always keep in mind that is really the reason we're here. And if industry can do it, then in fact it's much less appropriate for us to continue to do it. So we have to find a way to always move forward. But we are certainly not in an era where we can say this is ours and therefore we get to do it. In fact, we're being encouraged very strongly to make sure that
encouraged.
Please clear the landing pad. Raid incoming.
Actual education, welcome in. Raiders, welcome in. How you doing? What's shaking, actual education? How was your stream? What were you up to? What were you studying? Math, physics, all the above? Thank you for bringing the community over. I appreciate you. It is good to see you over here. Hope you had a great stream. If there's anything you want to share, any social links, any of that stuff, you would know you are more than welcome. More than welcome. Raiders, if you're new, I'm Nerdwino. I have a PhD in astronomy, and I worked at NASA, actually at the Jet Propulsion Lab, which we're watching a video about for about 10 years. I stream on Twitch Tuesdays, Thursdays, and Sundays at 6 p.m. and Wednesday mornings at 6 a.m. We will be live tomorrow. Tomorrow's stream might be a little later, but anyway, we generally talk about space, astronomy, human space flight, the human exploration of space, latest papers and research, play space-based games, do some space-based Lego, and do a little live astrophotography from our backyard observatory. We haven't done that for a long time. We need to get back into that. With the light nights, I mean, it's still not dark outside now. A little trickier. We tend to do more of that in the winter. But welcome in, Raiders. Is good to have you. Drop a follow, find your way back, get notified next time I go live. But yeah, thanks for coming over, Actual Education. I hope you had a great stream. Like I said, we're just watching a video about JPL, we're just past the first Mars mission, first Mars Explorer rover, if you like, and they're about to downsize the lab. So it's not going fantastic.
It's a challenge for us because that means just at the time we get our arms around something, we're told that's great, go somewhere else, do something else, do something new.
They're a skeptical bunch at JPL, I'll tell you that much. I will tell you that much.
No better example of doing something new than the 4th of July landing on Mars in 1997.
Spacecraft should have passed the 600 mark. Airbag should be inflated.
Pathfinder's airbag touchdown was as unconventional as it was daring.
I believe I have a firm signal.
And after bouncing to a halt and unfolding, a tiny rover had trundled off the lander, the first wheels ever to roll on Mars.
Well, it's my distinct pleasure to present to you the first rover on the surface of Mars.
The combination of an airbag landing, the tiny rover, and emoting engineers and scientists made for something very different than the typical NASA mission.
Yeah, opening a new era of exploration, as in the framework of the faster, better.
We know of, yeah, Phil Knox, exactly.
Pathfinder captured the hearts of people everywhere. The mission quickly became the poster child for Faster, Better, Cheaper's most forceful proponent, NASA Administrator Dan Golden. His ambition was to darken the skies with inexpensive but innovative spacecraft. And should a few of them occasionally fail, that, he had declared, was an acceptable risk.
I think all the elements are right here at JPL. And I think if you have confidence in yourselves to go to the cutting edge and not be afraid of failure, just don't be afraid, I think great things will happen.
Golden's pronouncements were always forceful, but they could also be contradictory.
It was such an exciting mission. It was the first mission in the whole series of Faster, Better, Cheaper. I really wanted that to come through. So I thought it would be okay to tell them don't fail. And I have to admit...
Dances with Dirt, yeah, true. Unexpected, but...
I wanted to see where the breaking point was.
Now he's back here on Earth, luckily.
Risk-taking was one golden message. There was a second one. What the consequences would be for not delivering missions on time and on budget.
So he would come out and berate us for the old NASA policies and practices?
Our record of overrun is beyond belief. Our record of not delivering on our promises is very open. And there's a sense if all we have to do is get it working and launch it, all is forgiven. Hopeless. That will never occur again. And we'll cancel the sick chickens. And we'll prioritize.
Cancel the sick chickens.
Dream at NASA of the future.
And then he would jump up and down with joy at the liberties we were taking.
Remember, question authority. You've got to do it. And if you're afraid, you don't belong here. And if we at headquarters or anyone forces a contract down your throat that's stupid, how do they say it? Just say no? I'm serious about that. You better not take it, then take it, and then when a problem occurs, say, I have an excuse. No excuses are accepted. Don't take shortcuts. And if you got a problem, say it, and if you overrun more than 15%, we cancel it. I want you to be sure you understand the rules. This is how Darwin works.
This was very tense. He would come here and he would scream at us. Quite literally scream that we were not taking risks, that we were too conservative. And, you walk away from that and you ask, I wonder if he's right. as much as you're defensive. You ask, was he right?
Oh, Darwin, yeah. Yeah, true. God, he's with his mama now.
Pushing hard on JPL was one part of Dan Goldin's plan to reinvent NASA. The Mars rock, hinting of
Not worth the pennies, right? So fucking lethal, yeah.
for America.
I will tell you that it's not the best way to motivate people at JPL. That doesn't go down well with those kinds of employees or personalities.
Astronauts were seeking a new destination. Any first step would be to explore Mars with robots.
Yeah, maybe anywhere, right? I don't know.
Effort at JPL was Donna Shirley, champion of Pathfinder's rover.
It's classified, I think, Kennedy. How you doing, Kennedy 104? Welcome in, by the way.
This is Allen Hills 84001, and it's had a huge impact. Whoops. I don't know why I do that. There's no orientation. And this is what they think might be a life form, except it's a couple orders of magnitude smaller than anything that's been found on the Earth. NASA decided, gee, we better start...
He's worth it, though, Dancers was there. He's worth it.
Mars mission, so there was a
What NASA wanted was to send a steady stream of spacecraft to Mars. Orbiters, landers, and even missions to bring Martian rocks back to Earth. All to be done cheaply.
The Mars exploration program currently has $150 million a year. That's about the size of a major motion picture. So you can pay your $8 and go to a movie, or you can go to Mars, whichever you like.
To cope, Shirley reorganized and introduced a radical new way of conducting business. After building a spacecraft, teams would hand over the controls to a single centralized group called Mars Surveyor that would fly all of the Mars missions.
The biggest problem I had was getting the project managers to work together, because the system at JPL and almost every place is set up so that if your project works, you're king. If your project doesn't work, you're a goat. And program? What program?
The program also called for using industrial partners more often. A strategy already well underway, as JPL built Pathfinder.
It's a cup of berries delivered, guys.
Denver assembled an orbiter.
Cup of berries.
Mars Global Surveyor.
We had a great team that shared the objective that we were going to make this launch on time, and we were going to make all the requirements, and we were going to do it within the cost and schedule. The team clicked. We had a good plan. I think we didn't deviate from the plan.
The plan for cutting costs included reducing the amount of fuel needed to go into orbit at Mars by using a daring technique called aerobraking.
And that requires using the solar rays, which are on either side of the spacecraft, to essentially drag through the atmosphere of Mars to gradually slow the orbit of the spacecraft.
Aerobraking had been tried only once before at Venus, where the atmosphere was more predictable. And it had been done as an experiment at the end of a mission, not the beginning. But these kinds of decisions were paying off in money and time.
It just almost made your head spin with how rapidly the whole process worked.
Mars Global Surveyor met its launch schedule and not only stayed on budget, but gave back to NASA $6 million.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition. And we have liftoff of NASA's Mars Global Surveyor as America begins its journey back to the Red Planet.
Sounds familiar.
Six solids separated. Everything is continuing according to the timeline.
Main engine and vernier chamber pressures are good.
It's good graphics, good animation, though.
And we have ignition. We have started the second stage engine.
He had to hold his breath for a really long time.
Third stage ignition.
Doing okay, enjoying the World Cup. Nice. Had a draw. Yeah. Yeah, they had a draw. Oh my goodness.
And we have confirmation that we have spacecraft separation. Mars Global Surveyor is the first of 9 U.S. spacecraft that will journey to Mars over the next decade.
Yeah, Dances with that, exactly. It's so true.
Very good. Spacecraft came off the launch vehicle, and we noticed that one of the solar arrays didn't fold out into its normal position.
Good afternoon and welcome to the Mars Global Surveyor post-launch press conference.
About that minor problem with one of the solar array panels, what is the worst case scenario? What happens if it doesn't get extended further? What are you going to try to do to fix it? If you get to Mars with it like this, do you lose anything? Do you lose power? What's the ramifications?
The fact that we had a crippled solar array wing at the very beginning of the mission, which was absolutely essential to being able to do the aero braking, really upped the stakes on figuring out what had gone wrong with the solar array deployment and trying to find a way to get it fixed.
Telemetry suggested the array had not latched into place. For the entire cruise, the wing would slightly sway back and forth. But tests on the ground pointed to a potential fix. Once at Mars, it was possible that the pressure of aero braking would provide the added push the panel needed to lock into place.
Maybe. That's kind of crazy.
And in early September 1997, after a journey of 300 days and nearly 500 million miles, Global Surveyor was bearing down on Mars. For orbit insertion, as with the cruise phase of the mission, assignments were split between Pasadena and Denver. Lockheed Martin handled the day-to-day monitoring and flying of the spacecraft, while JPL provided deep space communications, navigation expertise, and overall management. For project manager Glenn Cunningham, the events surrounding orbit insertion made for an especially anxious time. 4 years before, at just such a moment, his Mars Observer spacecraft had vanished without a trace.
I'm just going to drop over there in the corner, give you guys a chance. You know.
Mars up. And just say this time we should be one-way light time from the burn starts.
Could we switch back to the other pod for a minute? I want to see how far we're going because we're pretty close to coming into occultation.
Oh, great. So you're not even going to know. It's going to go behind the planet. You're not even going to know until it comes back out. That's crazy. Oh, Magister. Could have got a good little bump there.
FO1, this is navigation on Mars Ops.
Navigation, go ahead.
Going into the occultation, we are taking a close look at it.
Way to left, Suck. Welcome in. How you doing? Good to see you.
Minus 50 hertz. At this time in the mission, this is more than we had expected, which is a good indication that the burn is proceeding very close to nominal. Of course, we won't know until we see the other side of coming out of occultation, but right now it looks like...
Julian K120, welcome in. Hopefully getting jiggled just enough to actually work. Big Game, are you live tomorrow, bud, again?
This computer visualization going along. So as the telemetry at the ground, people were calling out, main engine on, main engine firing. And there's always that tense moment.
That's exactly how they sound, yeah, the way the life
behind the planet.
That's a little more rumbly than they sound. They're a bit more high pitched, but yeah, totally. In a vacuum, definitely. It's more of a feeling. It's more like vibes. It's more like vibes. That's.
For stations, lock on carrier. AGC levels are on -155 to 156.
I got lucky.
Celebratory peanuts there. All right.
Glenn, MOI peanuts?
MOI peanuts, okay. Good person, MOI.
Thank you.
All other attitude control telemetry looks pretty good. I'll go through it quickly. The control.
Back in the days when a red hat was just a red hat.
So looks like we had an excellent burn.
Go ahead, FLM.
Glenn, we've got a healthy spacecraft in Mars orbit, and we're go for aero braking.
Roger, I copy that. Couldn't be better. So all well and good, we thought. We did a couple of drag passes, and we noticed that the panel moved a little bit. And one day, the panel moved really significantly, and we got really worried.
One of the engineers said, as far as the aerodynamics are concerned, on the last pass, it went past the point where it should have latched into place. We said that's not physically possible unless the panel is actually broken. And he said, that's what the aerodynamics are showing. And I said, I need a new aerodynamicist. The panel was physically bending, not just not latched, but it was actually out there flopping in the wind.
There was a break in one of the hinge joints. The risk was that it would literally snap the spacecraft solar array off at that damaged point. So, gosh, this could be, mission catastrophic.
To protect the spacecraft, it was commanded up out of the atmosphere. The move bought the engineers time, but it also created a new problem.
We knew we were actually very much racing the clock at that point. We did have another gotcha. We realized that if we didn't get restarted aerobraking, we would get to a condition where the orbit around the planet would leave us in the shadow of Mars for more than 8 or 10 hours, when the spacecraft had really only been designed to survive about a 1 to 2 hour eclipse.
And if that were to happen, the batteries would eventually cease charging, and slowly, Global Surveyor would freeze.
Who's talking? What do you mean dances with that?
Good morning, and thank you for joining us at the Jet Propulsion Laboratory. The Mars Global Surveyor spacecraft has been in orbit around Mars for about 2 months now. Several members of the team are here this morning to give you an update on the mission.
We believe that we have identified a secondary failure in the solar array.
Oh, he's one of the mission
panel.
One of the engineers.
20-degree kink, so to speak, between the yoke and the inboard panel where the damper arm was caught.
The solar panels were designed to swivel. Rotating the broken wing might reinforce the panel enough to endure the stress of aero braking.
Or not, This is the thing, you never know, right?
But all of the delays had made shambles of the orbit plots that had been painstakingly calculated based on the need of science instruments to see the Martian surface in daylight.
To do the science it was designed to do needed to not only
Steph RX, exactly.
capture orbit down to the science orbit, but it needed to do it in a certain amount of time so the lighting conditions were appropriate for all the science instruments that we had on board. If the lighting wasn't right, a lot of the science instruments were not going to work.
An entirely new sunlit orbit plan had to be created on the fly. Then slowly the spacecraft was dropped back into the Martian atmosphere. The crippled solar panel held. In the days that followed came more encouraging news. Science discoveries. There were faint signs of an ancient magnetic field and images of geological features to outrival some of the most spectacular places.
It did such good work, you know. But it's so lucky that it survived, or good that it
There was a
survived, or
price
whatever.
to pay in having saved the mission. Aerobraking was originally scheduled for 4 months. It would now consume a year and a half. And that meant added strains on budgets and people at a time when 2 more missions were about to fly. They too would require urgent attention. And for every day that passed on their journey to Mars, the breaking point for faster, better, cheaper drew nearer and nearer.
Back some suits. That never seems to happen, does it? Funny. It's curious. It's quite a coincidence.
There are many reasons for the grip Mars has on the human imagination. Its mysteries beckon in part because of what our planets have shared in common. In the distant past, Mars appears to have been much warmer, a place where water in great quantities once flowed on the surface. But where did it go, and why? Some scientists think the answers to these questions might be found in the Martian atmosphere.
All of the geologic evidence that we see on the planet from early data from Mars suggested that it was once very wet and therefore apparently warm. Well, the atmosphere role in this story is, well, where did the atmosphere go? Why is it so dry? Why is it so cold? How did the climate originally start out as wet and warm? We couldn't explain that early on.
Still can't.
And we couldn't understand why the atmosphere changed so radically. How had the evolution of the planet got it to where it is today?
Deadscom, welcome in. How you doing?
Dan
Good to see you.
McLeese devoted his science career trying to answer these questions. He worked for more than a decade for the chance to fly a science instrument on the Mars Observer mission, the spacecraft that was lost just before reaching Mars in 1993.
I knew my career and those of all of my science colleagues, some of whom I had hired to begin work at JPL on that experiment, that we were all now looking at a very uncertain future.
Yeah.
It was going to be every man for himself trying to get your investigation flown. And now the question was, who was going to be in the lifeboat when?
That's a good way of putting it.
McLeese had to wait 5 more years before his lifeboat arrived. Mars Climate Orbiter was billed as the first interplanetary weather satellite. McLeese's science instrument, built to detect water vapor and carbon dioxide, was the main payload.
How we do for time? Oh, we got plenty.
Required substantial power and was highly sensitive to heat radiating from the spacecraft. All of these factors had to be reckoned with by engineers designing the spacecraft. The result bore no resemblance to Mars Global Surveyor. Climate Orbiter's shape was asymmetrical, having only a single solar panel that was to be flown mostly off to one side. It was only one of 2 missions that were to be launched in 1998, the reason why they are sometimes jointly referred to as Mars 98.
Mars missions were so cool. I mean, it's crazy the amount of missions they were planning.
Used rockets to reach the Martian surface.
Now we can't even get Mars sample return.
The budgets for the 2 Viking missions had been more than $1 billion. And even more astonishing from a budget perspective was that JPL and industrial partner Lockheed Martin had signed up to build and fly these 2 spacecraft for the price of Mars Global Surveyor. It's commonly believed that this 2 for the cost of 1 idea originated at NASA. But the agency's then Associate Administrator of Space Science, Wes Huntress, calls that folklore. The original proposal, he says, came from Lockheed Martin.
I was facing a decision about what to do for that flight opportunity. Are we going to do another orbiter, or are we going to do a lander? The science community was at odds as to which they wanted. Some wanted an orbiter, some wanted a lander. And at the time I thought, well, I've only got money to do really one mission of the cost of Mars Global Surveyor. So while worried about what decision I'm going to make, Lockheed Martin came in, said, we can do two. I think we can do our lander and we can do the orbiter if we take advantage of certain ways in which we build our spacecraft and build them together, so we're not building one spacecraft over here and one over here.
Wait, hard or soft? Yes, please.
Do some things in construction so that we could keep the cost down and do to it. So
Donna Shirley's reaction was not nearly as enthusiastic.
I bet it wasn't.
JPL signed on, knowing that if it didn't, some other place would.
You can see how crowded the schedule is. We're beginning to understand how hard it is to turn out production line spacecraft on this kind of time.
That's crazy. I mean, this was incredibly aggressive. Like,
2 missions for the cost of one was taking faster, better, cheaper to an entirely new level, giving pause to even gung-ho Pathfinder engineers.
I remember people bragging early on that they said, yeah, we're going to do 2 for the price of 1. Good God, is that really? Oh.
John McNamee was picked as overall manager of the 2 missions, though he had to be talked into taking the job. McNamee started out his career in construction, but he went back to college and earned a PhD in aerospace engineering.
As one does.
Early on at JPL, he was seen as an up-and-comer. He had been in charge of mission design for Pathfinder and was known for his no-nonsense style and being a tough negotiator.
You can't afford to spend time with hundreds of people in rooms for hours and hours, days and days, trying to figure out what to do. You take as much data as you have, you make a decision quickly, and you move on. And you only revisit a decision if, the preponderance of the evidence says you really screwed up. We certainly made some...
To have any hopes of success, McNamee was convinced he would have to run an even leaner and meaner team than even Pathfinder had been.
John McNamee took it to an even more extreme level in the sense that he's, the JPL fingerprints on Mars 98 were relatively light. This was, we're going to let Lockheed Martin do it the way they want to do it. And that itself was a challenge to the JPL culture because it's like, well, what do you mean we're going to not understand what these guys are doing? It's still got a JPL mission. Why don't we have people overseeing what they're doing? And John was very adamant about the fact that he didn't want to do that. He couldn't afford that the only way to accomplish this was to let Lockheed do it the way they wanted to.
This hands-off approach was not welcomed by a number of JPL engineers. Most were accustomed to peering over the shoulders of contractors as part of their responsibility to assure mission success. This cultural divide, born during Pathfinder, continued to widen and deepen.
I don't know that we were consciously doing it at that time, but we really were creating a separate culture, and there were 2 cultures. I can remember walking around one evening in Building 230, I think it was. It's after hours, and most of the doors were locked, and I was looking for a paper clip or a piece of paper or a pencil, and I knocked on one door, and somebody behind the door says, yes. And I said, I need a pencil or paper clip. And the voice said, are you a Martian? And I said, no. And then they opened the door. So, I mean, there was a group of people who were very, very unhappy that this divergence was taking place.
No one understood both sides of JPL's cultural divide better than John Cassani.
That's funny.
In charge of flagship missions like Voyager, Galileo, and Cassini. But he was now encouraging the lab to adapt to faster, better, cheaper. He was also serving on review boards to monitor the progress of the Mars 98 missions. Kasani saw serious engineering challenges to be sure, but no showstoppers.
I honestly can't say that I was terribly concerned about the mission. But what I didn't have a perspective of during that period of time is just how thin we were in terms of people working on the project. Most of the work was being done at Lockheed Martin. And so, say you're on a review board and you sit in the review room, you don't see what is actually going on.
As for make a deal and stick with it, that concept was not proving to be a two-way street as NASA began adding on unanticipated and, from the project's perspective, unwanted cargo. For the orbiter, there was only the addition of a camera.
Only.
The lander, the requirements creep became a source of ongoing disagreements. First, a descent imager was added. Then came pressure to include a science instrument from Russia, a gesture meant to encourage cooperation with a former Cold War foe. That was
all on a budget.
By lobbying for a stowaway inside the Russian.
Oh, geez.
A microphone to listen to the sounds of Mars.
I didn't know about all this.
The biggest battle was over two other hitchhikers, a pair of basketball-sized penetrators that NASA viewed as a new technology demonstration. They were to be released just before the lander's entry into the Martian atmosphere. Then they would free fall all the way to the surface, hitting the ground with a force equal to 60,000 Gs.
Okay, I'm not even gonna.
If still in one piece, the probes would search for traces of water ice and serve as precursors to one day scattering other miniature monitors all across Mars. This
cool idea, but
Deep Space 2 was also assigned to JPL. Chosen to lead the effort was Sarah Gavitt.
There are a lot of challenges in designing a system that will survive a crash landing. We started off very early on the mission with a very aggressive test program.
Yeah, that's pretty aggressive.
Really have tested it, we probably would have needed 1,000 probes that you fired in under a variety of environmental conditions. We didn't have the luxury of doing that. And so we did have to take some shortcuts in the testing area.
Deep Space 2's breakneck schedule demanded making decisions about risks that no ordinary mission would contemplate. And when this experiment was elevated to project status, expectations for success were raised too.
John McNamee did not want the Deep Space 2 probes on his spacecraft, and I don't blame him. We were just going to make his mission heavier and a little bit more complicated.
Yeah, I don't blame him either.
He was unable to keep Deep Space 2 or most of the other add-on payloads off the lander. And a year from launch, he saw an even greater threat looming. This one from inside JPL. The centralized team that was to fly the two spacecraft were still busy finishing aerobraking for Global Surveyor. Where, McNamee asked, was a detailed schedule for the new Mars missions. When would staff have the time to learn to operate the two spacecraft? As for the suggestion of delaying training until time of launch, that, McNamee declared, was a fatally flawed idea.
And it was just this continual, what I call the death of 1,000 cuts. And I just realized that really bad things were going to happen, and I was watching people suffer. The program was out of control. There was no way to fix it. No one would listen. I was so concerned about it that I actually retired. I just couldn't stand it. And people were killing themselves. They were absolutely killing themselves trying to make this work. And so the day I made the decision to leave was pretty much the nadir of working at JPL, which is very sad because you hate to go out on that note. But we had a great
that is
retirement
sad.
party, so it worked out.
Besides official proclamations of a job well done, Shirley's retirement party featured humorous skits in keeping with the JPL tradition of its day. Then, as part of letting go, Shirley began passing away items from her office.
We can do that. Is Dan McLeese around? Okay, Dan. Now, Dan asked me for this, and nobody wants to own Mars more than Dan.
Shirley's final gift was a not-so-subtle dig at those she believed still were not heeding her warnings.
That's funny.
Book that's only published on the internet. It's called Managing Creativity, and I modified the title to Managing Creativity, a practical guide to inventing, developing, and producing innovative products, or A Prophet is Without Honor in Her Own Country.
What can I say? Hey, how you doing?
3 months later, Mars Climate Orbiter was being readied for launch, with Mars Polar Lander scheduled right behind. A list of problems continued all the way onto the pad. Some software...
That's just never good.
The last minute...
Oh, for God's sake.
...through the full rigors of testing. It was a risk the project was willing to take, as the alternative was to delay the mission by 2 years.
Soon, Sofa King Lethal, yeah. The Band-Aid is about to get ripped off.
Here we go.
Unceremoniously.
A review board of hard-nosed veterans also delivered the verdict that the 2 missions were ready to fly. The JPL Lockheed team had done what many thought impossible. They had built 2 spacecraft for the price of 1 and delivered them on time and on budget.
For me personally, 15 years ago, I was hammering nails in 100-degree heat on the roof in Texas, so I'm very excited to be doing what I'm doing right now as opposed to that.
Rick, about Aviation Week, kind of a broader question on the lower cost missions. Are you guys going to maybe go back and do an operational scrub of any sort beyond what you would anyway?
I do not think spending huge amounts of money necessarily guarantees success, and we have examples of that. And I think the thing to remember is that the complex nature of this business sometimes does come back and get you with little problems. And I've said this before, the surprising thing is not that we have scares or problems. The surprising thing is that we have so few of them. It's a very difficult business.
RCO, report ready to go for launch.
Ready to go for launch.
And we have liftoff of NASA's Mars Climate Orbiter as we continue to mysteries of the red planet.
We have liftoff of the Delta II rocket carrying the Mars Polar Lander, NASA's first visit to the red planet's southern pole.
View from the second stage of the Boeing Delta II vehicle.
There's the rain cloud we're flying through.
He'll be along very shortly, Sofa King Lethal. Very, very shortly. They lost... When did... Well, I don't want to spoil the story for anybody.
Boosters burn out and jettison. And we have jettison of the solids. Again, a beautiful view from the second stage of the Delta vehicle.
Oh shit, I think we have ads incoming actually. Let's see. Ads in 2 minutes, okay.
Everything continues to go right on schedule. No issues or concerns are being addressed at this time.
They didn't eat enough peanuts, that was the trouble. They needed more Lucky Peanuts. Bye.
4 months after the launch of the 2 Mars 98 missions, an elated Ed Stone presided over JPL's annual State of the Lab address.
Well, it's hard for me to imagine a more exciting time than the era we're in right now. 6 launches in 6 months. never before in the laboratory's history. It is great. It's great. Well, not only are these wonderful missions, but
For nearly a decade, Stone had worked tirelessly to adjust the culture of JPL, to transform the nature of the lab's missions, and to fundamentally alter how the staff performed its work. And now all of that effort was coming to a head.
I've been working at JPL on a part-time basis at least since 1972, starting with Voyager. And I can't remember a time that's more exciting than this one. I really, literally cannot. Even though the Voyager encounters were wonderful, they were spikes. What we have now is a continuum.
But just 2 days after his address, one of those 6 missions, a space telescope built by a university partner, failed. An event set in motion when its cover ejected prematurely. The 2 new missions on their way to Mars were struggling too. Both were experiencing problems related to sunlight conditions, the result of design flaws. The solutions required flying the spacecraft in different orientations than originally planned.
Oh my gosh, it just seemed like it was another one of those periods where one thing after another went wrong. Every day he struggled.
Oh, ads, guys.
Ended up essentially putting the...
I'll pause it. Be right back.
In addition to penetrating the forest canopy all the way to the ground, the other huge advantage the biomass mission brings is its ability to combine images from different satellite passes to gather information on forest height. By combining data from these passes, scientists can get a very accurate estimate of forest biomass from orbit. Here's another biomass image of northern Brazil showing wetlands below the dense forest canopy in pink and red. As you can see in this third image over Indonesia, biomass's ability to penetrate all the way to the ground means it's also useful for generating topographic maps of forested areas. It's going to be super interesting to see the data we get from biomass when it gets into its stride and starts science operations. That's today's video. Have an awesome weekend. I will see you back here on Monday. Another new exoplanet today, but this one is a first. It's the first exoplanet directly detected with JWST and a coronagraph on the MIRI instrument. Because of the bright starlight and because planets are dim and very close to their stars, at least from the perspective of observers on Earth, direct detection of exoplanets has so far proved very difficult. Enter the coronagraph, a device that blocks the light from a central star so astronomers can investigate the area around the star without the bright starlight overpowering everything else in the image. It effectively creates an eclipse of the star for the instrument. Our current theory of star and planet formation is that stars form from a rotating, collapsing cloud of gas and dust, and planets then form from a disk of material that surrounds the new star. The exact timing of this is not clear. We had always assumed the star formed first and then the planets later, but several new observations suggest that the star and planets actually form at almost the same time. In either case, it's much easier to try and find planets in disks of material that we are looking down on from the pole than systems we see edge on. Think about looking down on our solar system from above. It would be much easier to see the planets this way than if you were looking at the solar system edge on to the disk. The team that discovered the new planet used all this information to their advantage, focusing their search on young stars with planetary disks that were known to be oriented face on to us based on previous observations with other observatories like the Hubble Space Telescope. As you can see in this image of the star, TWA7, there are 3 faint rings or gaps visible in the disk around the star, and astronomers assume that gaps like this indicate the presence of a planet. The difference here is that in the inner R1 ring, JWST has actually detected a source, and after a lot of checking and double-checking, the scientists have concluded the source is a planet roughly 30% the mass of Jupiter, orbiting about 52 astronomical units from the star. Relatively speaking, this is a very small planet to detect directly, and the researchers believe they can use this system to find planets with just 10% the mass of Jupiter in the future. Other even Hi guys, welcome back. Thanks for sticking out through the ads. We're gonna watch a little bit more of this, and then we'll finish the rest on Thursday. Tomorrow,
tomorrow's stream, the 6 a.m. stream, I'm actually going to move that to 10 a.m. because I want to work on the Q. Welcome in. I want to work on the spectrohelioscope tomorrow, and we need the. Yes, it is dead scum. That's to stop you from gaining an unfair advantage. So there's a bit of it that's hidden. You can't tell what's going on. Interrupting now would be bad luck. Yeah, I've got bad news about that. Yeah, so tomorrow's stream, not 6 a.m. as usual, it'll be 10 a.m. because I have to take Mini Nerd to camp tomorrow at like 8:30. So if I start streaming at 6, I'm only going to be able to stream till like 8 or 8:15 or something. So we'll start at 10, and I'll be able to stream until maybe 1. So we can spend 3 hours working on the spectrohelioscope, whatever it is, I don't even know. The spectroscope for the sun. Mechaholic, ooh, 98.3, nice, Mechaholic. Guys, play the drop game, drop for 99, and you get a 1-month gifted sub to the channel. Also, don't forget our Melissa and Dinar collab on Sunday and our 4K follower party following that. Probably should rephrase that. On Sunday night as well. We'll be playing some games. I don't know what we'll do. We'll have some fun. I'll have some patches to give away. Some stickers, whatever stickers I have left. But yeah, let's find out what happens. It seems like most of you already know what happens, but let's find out what happens to the Mars Climate Orbiter.
Comatose state, so we can get through the launch of Mars Polar Lander and get it going okay. And then we said, okay, then we'll come back and we'll deal with the issues that we had on MCO. Mars Polar Lander had its own issues shortly after launch, and so we coped with that. The spring and summer.
I'm sure that these things won't just both disappear without trace, you know?
My entire life.
Mr. Brain, how you doing?
That was only the beginning.
You doing? Good to see you.
The journey to a planet is usually considered the quiet time of a mission.
Oh, it's going to be quiet.
Mars Climate Orbiter, due to its shape.
Going to be quiet.
With the solar panels swung to one side, radiation pressure from the sun was causing the spacecraft to slightly rotate.
They knew that though, right?
Actually feeling the solar wind, the solar radiation pressure, and that's kind of blowing it off course, a little bit like a sailboat off to the side. And you have to know that, but of course there's no good way to know that. You have to guess what the reflectivity is of the foil and how much area is shadowed, exactly what's going on there.
Quite awesome, yes. Quiet awesome.
Correct for unwanted motion, small gyroscopes called reaction wheels were spun up.
So cool. Hooray for reaction wheels.
They began spinning too fast.
Oh, God.
And yet another force in the form of thrusters were used to desaturate or de-spin the reaction wheels.
What a nightmare.
And you have to know, how long did it fire its thrusters and how much force was applied. And a mistake in any of those means you could be kilometers off course, because those things build up over hours, days, weeks, and months on the way to Mars. And you can actually get quite far off course if you don't know exactly what's happening.
Cool. I feel bad for these guys. I mean, they were forced to do this for next to nothing with an incredible time crunch and requirements that kept changing and being added to, not changing for the easier. And
thrusters.
These nuts. Oh, that's good.
Hours.
Good.
Unanticipated chore that added more pressure on a team that had been stripped down to a skeleton crew. Only one full-time navigator was assigned to the mission.
Jeez.
And during the first 4
months, like they need like 6.
Navigation data from the spacecraft was not even usable because of a software error.
For God's sake. So they actually didn't need any navigators then?
Seemed slightly amiss in the predicted plots.
You think?
We knew there were some funny things going on with the navigation products. It was in that gray area between it. It wasn't bad to the point of you have to do something about this now or the mission's over. It wasn't just fine. And so often, when there are one problem after another, I found in my own role, you really have to judiciously prioritize.
The navigator and his supervisor.
Without testing though, right, Q?
In phone calls, emails, and even face-to-face meetings. But a formal report was never submitted, and the source of the small discrepancies was never tracked down.
Mr. Faster, better, cheaper?
We failed to properly record it as an incident surprise anomaly. That was probably the devastating step, because it was an issue that was recognized. I remember talking about it in the staff meeting. The trajectory wasn't performing as expected, and I just don't know why we never entered it into the system the right way.
Wait, so
over time, these navigation worries came to be viewed as something of a theoretical irritant. For while the course plotting of a spacecraft can rightly be called rocket science, it is surprisingly not an exact science.
And of course, there's no GPS out there. There's really no way to know where you are except tracking with the big Deep Space Network antennas. But that's only in the line between you and me. So it's only one component of the three.
Yeah, you can only measure the radial velocity, right?
By measuring only one component, you sort of have to unfold through understanding orbital mechanics and understanding what the spacecraft is doing, exactly where it is. And it turns out that's a pretty complicated process.
Yep.
So in a sense, you're trying to figure out where this thing is in this cloud out here, and all you can do is...
You're trying to figure out where it is by figuring out where it isn't. As Bicami's Redeem says on his stream.
It's right here. But it could be right here and going this fast, or it could be right here and going this fast. You don't know the this way, right? The this way you only can do by building up over time. Well, it was here, and then we think it was here, and you begin to eventually converge in on it. But that takes months. The thing that helps you is that it's not just randomly moving. It's in orbit around the sun, and so it has to be moving in a predictable way, except for the times in which something else is pushing on it. And the something else that's pushing on it are...
Yeah, what's the worst that could happen, Captain Failure? It's not like this thing is just going to slam into Mars and never be heard from again. That's
2 months before arrival at Mars rose another problem. During a trajectory course maneuver, the spacecraft's solar panels seemed to have jammed. A problem that, if not fixed, would doom the mission.
It is just literally one thing after another. Huh?
We got to fix this problem now, or it's over. That was going on at the same time the problem that eventually killed us was manifesting itself.
The solar panels...
No, there's not really a way of doing that, Kennedy 104. We still rely on DSN for the most part. I mean, they have star cameras and things like that can help, but...
was solved, but the solution took the better part of a month, leaving undone other scheduled work.
Yeah, exactly, Descom, yeah. Star camera.
Predictions still weren't converging.
That can help. But you still, you can still be off by kilometers, right?
Raised to over 200 kilometers. But after the maneuver was
I think this is going to go fine.
New plot showed the aim point was 72 kilometers lower than expected. With tensions running high, the navigation team leader argued for yet another maneuver to push the spacecraft even higher.
I don't think you should do another one.
People were used to the navigators, basically saying if they didn't understand where it was super precisely, it was like, well, they always have so much margin. Those guys are, they never miss anything. And when they were trying to communicate, no, really, we really don't understand where this trajectory is going. We're seeing things in the data that don't make sense to us. The message that was received was very different, I think, than the message that they were trying to communicate. And so this was another one of those cases of not knowing how close to the edge we were on this particular mission.
Given the concerns, a small subset of a review board met by telephone to consider an emergency maneuver. No navigator was invited. The outcome was to press on as planned.
Yeah, it's amazing how if you don't have the right people in the room, you can...
Worrisome, they still showed the spacecraft having twice the altitude needed to safely go into orbit. Last-minute changes, the reasoning went, might introduce new dangers.
I mean, that's also fair, right? That's
Among those on the phone call was Richard Cook.
Oddly, a lot of the senior leadership of the development project and the operations project both had navigation backgrounds, or all had navigation backgrounds. And I think that created this model that this is something that we know how to do, and that there was not, clearly proper paranoia is one of the things that we, believe in very strongly around here. I think that because of that comfort with the underlying technical problem coming from the management, there was just not enough paranoia. And instead, if anything, there was the opposite, which is you guys are too conservative. It'll be okay because it's always okay.
Well, maybe.
Before the decision not to conduct an emergency maneuver, climate orbiters saw this image of Mars. It would be the first and only one the spacecraft would ever see.
I feel like we should stop it here and leave it as a cliffhanger.
Mission Control of the Jet Propulsion Laboratory.
Oh, the graphics. Oh my God.
Operating Division of the California
JPL's live TV coverage of the orbiter
You'll see more. We just won't get the pictures. Yeah.
As of September 23rd, 1999. Given the hour, there were only a handful of people in the small mission support area for what many believed would be a routine event.
team resides and is watching all the telemetry come on in. At the Lockheed Martin Center, they do the actual commanding.
Telecom systems go. I just want to let you know the stations look like they're in lock at the appropriate level, and everything's nominal.
Windows screensaver. Yeah, I remember that. I know what you're talking about.
Operations
Manager
Manager Sam Thurman. John McNamee was there too. He was now working on a different mission, but he had continued to be in close touch and his opinion still mattered. Looking on from just outside the room was Glenn Cunningham. He had recently retired, but found it hard to stay away. Moving into Cunningham's role with responsibility for flight operations for all of the Mars missions was Richard Cook.
Continuing to report nominal as we head into MOI.
The altitude was still, in the days up to arrival, was still hanging around the 150, 160 kilometer range. And so everyone was like, yeah, it's going to be lower than we want, but still okay. There was one last update of the altitude, and that was at about probably midnight or 1 o'clock, where the data all the way up to that point was used to calculate a new idea of what the altitude was. And it dropped to 110 kilometers, which was frightening. But I think, we still felt like that was above the surface.
Oh, man.
Spacecraft.
Systems FOM. FOM systems, go ahead. Hey, can you ask Telecom to forward a predicted AGC level once we are in the burn attitude? Will do, standby.
This is going to be... yeah, exactly, Captain Failure.
At this time, for the commanding of the onboard
Yes.
Yes. That is it. The MOI burn. Yep. Next event again would be loss of signal with occultation start at 9:05:41. That would be MOI.
You could relate almost exactly the time at which we lost lock on the signal as the spacecraft went behind Mars and what altitude the closest approach was going to be.
Okay, Station 43 reports that they dropped receiver lock at...
It's going to be negative altitude.
The last signal seen in the FFT was at 090502. Roger that, thank you.
We got LOS unusually early, and I looked to go mark the spot on that graph of where it had occurred to see what the flyby altitude would be, and it was almost off the page.
Uh-oh.
So at that point, I remember thinking, uh-oh, we really got a problem here.
FOM. Yes, sir. Could you call me at 79134?
Call me at 1-800-OH-SHIT, please.
The loss of signal had occurred 39 seconds earlier than predicted, and that was not good news.
Yeah, they were on letter instead of A4. That's what it was.
Thanks, Steve.
If they'd been on A4 paper, they'd have been fine.
Then we had I think it was about 20 minutes we had to wait out the burn itself and then, look to reacquire it.
Attitude, this is systems.
Systems attitude. Read update is complete.
Copy, thank you.
Joining us is Dr. Dan McLeese. This is a big deal for you here. You've got one of the 2 science instruments on board the spacecraft.
Yeah, this is very exciting.
Yeah, that's
right.
A microphone, and I was going through the sequence of events, looking at the clock, looking at the timeline, and listening to what the operations people were.
I don't think they got contact back with the Entropic. I can't remember though.
For exit of occultation, scheduled to be at 9:26:50.
If I remember rightly, it never re-established communications.
What a typical Martian year is like from the perspective of weather. And as I was talking through near the moment we would have been in orbit correctly, it was clear that something was very wrong.
Yes.
I didn't know what to say on live TV, so I just walked away from the microphone. I walked into the room where the telemetry was coming down from the spacecraft, and people were saying, "It looks like we're going in close. Looks like we're closer than we thought we would be." And I'm saying, "There's an atmosphere. This is not the moon. We are not going to make it."
Okay, waiting for acquisition of signal. Okay, let's listen in and see if we get AOS.
And everybody's going, "Oh, if we just can get past the entry point, we'll see if we come out the other side." And I just couldn't believe it. I couldn't believe that people were even imagining such a possibility. I knew it was over. Twice unlucky? What? This is not possible.
And we didn't reacquire him. And I remember talking with the so-called the ace, the person that talks directly with the stations. He was talking to the station operator, saying, I'm not, were you seeing anything at all, any sign of the carrier wave? And it wasn't happening. And that's when, all right, we're going to have to get off script.
I think there are 1 or 2 possibilities. It take a while to get it torqued back around and get a signal.
So I remember a voice in my own head saying, follow your plan. The emotional part of it became tolerable by having something to do that had been, worked out and getting to it.
Either way, there are things that it will do other than just sit there. Okay.
And I'm producing this out of our TV control room, and no one's talking on the comm lines anymore. That's gone silent, and people are starting to pick up their telephones and communicate. It's like, what's going on here?
Never good.
Time comes that we're supposed to reacquire the signal. There's no signal. So 5 minutes goes by. 10 minutes goes by.
This is Mars Climate Orbiter, Mission Control. Now about 14 minutes past the point we would have expected to receive signals from Mars Climate Orbiter as it reappeared from behind Mars.
David Seidel, who was doing our commentary, gets off mic and calls me and says, I don't know what's going on. What is it that I'm supposed to say? Well, I didn't know what was going on. So I jumped up and I ran as fast as I could over to the building they were in, building 264. And as I was running, I was saying, I don't have a contingency plan for this. I don't know what it is I'm going to do when I get up there. But I've got to have a decision made by the time I get off that elevator.
Okay. Yeah, I don't think we'll probably not do the live shots. But hold on that. One thing at a time, okay? Hold on. Yeah. We'll get Richard in here. We need to shoot him with a camera.
I had to grab Richard Cook out of the mission support area and have him go on live to tell whatever it is that we did know. We needed to tell that right then and there to the world.
This is
Kennedy.
Of the Jet Propulsion Laboratory. Joining us now is Richard Cook, who's the Mars Surveyor Operation Projects Manager. Can you give us a quick update of what you know?
What we're working on right at the moment is the spacecraft has a number of autonomous recovery processes that it goes through when it has a fault. We believe that we are in all likelihood in the midst of one of those. So we're going to be monitoring it over the next few hours to see what happens. I think we will. Obviously, we will as soon as we find out something. We'll let everybody know. But at this point, we're still very confident that we're in orbit and we're going to see this spacecraft signal sometime in, like I said, in the next few hours. It was about that same time when the navigators came in and said, now we've got data all the way up until the point at which it went out of communications. When they processed that data, it dropped to 60 kilometers, right, which is obviously below where we thought it was survivable. And so that's really when it hit the, fan, so to speak, and where everybody began to worry that
yeah, it should buff out. I mean, it's not technically a complete failure because, when we go back, we'll be able to switch it back on, put some new paint on it, and throw it. It'll be fine. It'll be fine.
Briefing this morning to give you an update on the status of Mars Climate Orbiter.
A few hours later, not long after sunrise, what had been planned as a celebratory press conference was instead the beginning of a long search for the guilty.
Robin Soriano with Florida Today. Could you tell us who is responsible for sending the navigation commands to the spacecraft?
But you must have a list of potential suspects already.
This isn't the first of the smaller, faster, cheaper, better spacecraft that you've had problems with. Covered a lot of JPL missions, and I realize you don't get the real final tracking until you get close to the planet, but I can't recall an era this large ever.
It was just a terrible, terrible experience, terrible day. And no matter what you say in that sort of moment, you're going to cause ripples, right? I mean, the team is, struggling.
Yeah, it doesn't really make any sense.
And so,
no, it says with the
statement about what happened, other than we lost the spacecraft, you get into that feeling of the team kind of coming apart, and it was just turned into this incredibly divisive thing, which is unfortunate, obviously.
Just to follow up on that last bit, I wonder if you could just tell us literally over the next 8 hours, literally, what are you folks doing?
Right now, we have a fully staffed flight team, both here and at Lockheed Martin in Denver. We're going to essentially begin to dive into this navigation issue as soon as possible, probably as soon as we walk out of this room.
All right, I think that's a good stopping point, because don't forget, we still have Mars Polar Lander. We haven't. Everything could be redeemed. Everything could be redeemed. Potentially. Maybe. No spoilers. Yeah, it's good though. It's good. There's more. Oh yeah, there's more. There's more. The other one's coming in right behind it. They launched them a few days apart or weeks. I don't remember the details, but yeah, they were both on their way at the same time. Guys, I'll be live again tomorrow at 10 a.m. We're gonna shoot for 10. I have to take Mini Nerd to camp, so instead of the 6 a.m. stream tomorrow, it'll be a 10 a.m. stream, and we're gonna work on our spectrohelioscope graph thing. That is where the issue. Yeah, I mean, you could use that as a potential metric to track the problems. But a cheaper, faster mentality did have that they might have more failed missions. Yeah, Kennedy. I mean, it was inevitable, right? It's inevitable when you try and do way, way more for way, way less money and with way, way less people. You can't, right? There's a reason why. So there's going to be, but for the successes, it works out great. Let me see. So don't go anywhere though, guys. We're going to raid out. Let's see who's on this evening that we could go and raid. And like I said, back on tomorrow morning at 10 a.m. for some live solar astronomy, maybe. Tom's on. We'll raid Astro Canuck. You guys can join your tabs. There you go. That'll save you a lot of trouble. Wait, did that work? I guess it's working. The maze game, I will of course give you the maze game. The scores for the maze game: Steph LRX 305 points and Black Cat's Manor. Guys, make sure you're following Black Cat's Manor as well, because Black Cat is awesome and also does solar astronomy. Might have some tips for us. There's a quick shout out for Black Cat's Manor. I feel like this raid isn't going to work, but we'll see. We'll see. I'm not seeing a raid now button, which I would expect to see, but that's okay. Guys, I'll be back tomorrow morning, 10 a.m. And then Thursday night at 6 p.m. Don't forget we have our collab stream with Melissa in Denial on Sunday at 4 p.m. Pacific. I should say 10 a.m. Pacific tomorrow as well. Yeah, thanks for hanging out with me. I really appreciate everyone being here. I had a good time. I love this JPL history stuff. I've really got into it more than I expected to. But yeah, hopefully I'll see you all tomorrow, if not Thursday. And then Sunday night after our Melissa in Denial collab, we'll have our 4K follow-up party. Enjoy Astro Canuck stream. He's an awesome streamer, super great guy. I got to hang out with him at a couple of Twitch cons, and yeah, I'll see you all tomorrow at 10 a.m. Pacific. Peace.
Holy potatoes. No. Oh, we still have lots to talk about. Lethal, how are we doing? Misadventures in Astro Entropic Universe. Steph LRX. Welcome in. Nerduino Actual. How are we doing, Raiders? Welcome. Sofa, good to see you. Thank you so much for joining in. How was the stream?